Good afternoon, everyone.
Good afternoon. Can you hear me?
Yes, sir.
Okay.
On behalf of Marthandam College of Engineering and Technology, I am delighted to welcome you all to today's session of this Atal Fdp on emerging trends in space and computing technologies. Firstly, I would like to extend a warm welcome to our esteemed resource person for today's first section, Dr. R. Vijay Arjunan, Additional Professor of Computer Science and Engineering at Manipal Institute of Technology. He is an experienced academic and researcher with more than 20 years of experience in computer science and engineering. He obtained PhD in computer science and engineering from Shankara University in 2013 and Master of Engineering from Satyabama Institute of Science and Technology in 2005. He has published over 50 research articles in various international conferences and journals. His research interests include computer vision, image processing, machine learning, deep learning, and data mining. Also, he is a life member of Broadcast Society of India. Before we begin, I would like to welcome all the participants present here to this session and expecting your active participation in this FTP. Welcome you all. Now, I would like to hand over the session to our esteemed resource person, Dr. R. Vijay Arjunan. Over to you, sir.
Hello, sir. Hello. Hello, sir. Please take over the session, sir.
Madam, can I start? Hello, thank you. Can I start, madam?
Yes, sir, please. I think ma'am have given introduction about you.
Okay, okay. So I'll start my presentation.
Yes, ma'am. Yes, sir.
Okay. Yeah, my screen is visible.
Yes, sir. It is visible.
Yeah. Good afternoon, everyone. So I thank the organization committee for giving me an opportunity to give a topic on impact of human-computer interface. So now we had a beautiful technical talks with varying experts last 5 days. So this particular presentation, what I'm trying to do is something connected with how we can better design with some kind of a interfaces that we use in a daily life. Okay. So to get started, okay, to get started with the presentation, okay. So let me ask or let me interact with the audiences, okay. So how many times we interact with a computer, okay, on a daily basis? For example, maybe we can think about how many times we interact with our PC system, mobile phones, or smartwatches, or ATM websites, or so many things. So, because we understand that in our today's life, we have an inevitable attachment with many computers which are around us. Okay, maybe in the form of a PC, maybe in the form of smartwatches, ATM websites, so many things we keep interacting. Okay, now the question mark is like when we interact with such a kind of what do you call like a designs, okay, we come to an understanding that a few designs are okay and few designs are not okay. Okay, so it's like we get frustrated with some designs. Okay, so all these things are why means that a design part is not taken into consideration wisely. Okay, so there are list of confusing websites that we go with. Okay, there are some well designed websites which are so appealing and which are being in the market. All right, so for example we can say Google search. Okay, so it is one of the very fantastic design. So these aspects have paved way for development of human computer interfaces or human computer interactions. Okay, so with that, let's start this particular presentation. Now generally we call this HCI is like human computer interface or human computer interaction. We should not come to an understanding that computers are not only computers, like whatever smartphones, whatever smartwatches, whatever that particular devices which are getting connected with the outside world, everything we should think that it's like a computer for us. Okay, so we have to design such a kind of a computer science designs with the utmost care. Now to introduce human computer interface, it refers to the design and use of interactive computing systems for human use and the study of major phenomena surrounding them. So this is the key focus. Now this particular human computer interface, why it is so popular now and why much importance is given now, it is not only for example technological based peoples. Now you can see this human computer interface or interacting with the design is not only with engineers, it is with the doctors, it is with financial experts, it is with anybody. Okay, so we have to take care of the first thing that we can discuss about this today is like the design principles. So, what are the key design principles an expert should undergo or should look into for designing a particular interface or design properly? The first thing that a particular expert should take into consideration is usability. Now, when we talk about usability, so what is that? Supposing when we have a particular design, that we see, for example, when we go to an ATM center, we have a particular screen, and that particular screen, it should be easy to learn. So the design engineer, the main focus of him was is to design the particular system with a easy to learn design, okay, and efficient to use, and it should also satisfy that particular user. Now, we being in this particular South Asian part, okay, so we have different banking system, but we are attracted to certain amount of banking designs, because those particular banking systems which we are interfaced with a lot are easy to learn, efficient to use, and it is getting a satisfactory moment for that particular user. Also, one more concern is we should use a very less cognitive load for interacting that particular system. So let me brief. Okay, so what is that particular cognitive load? So some banking systems, for example, I'm just quoting the banking example because everyone is using that particular banking system very often. Okay, so cognitive load means, so we should not break our brain to understand how that particular interface is made. So it should be very, very easy. Even for a layman, that particular design should be easy to learn. It should be in an attractive way. So that is what called usability. So the expert should be able to make that particular system very usable. Okay. The second one is user-centered design. So the aspects about user-centered design is the design should be based on the needs, preferences. For example, supposing if a website is designed for youngsters, for example, a gaming website. So based on the preferences by smaller age group of boys and girls, that particular design should be made. Not that design should not focus on the persons who are aged above 40. So it's like that. Okay. So those kind of information, he has to keep it in the mind while he is developing. Okay. And for that, he needs to have a continuous user testing and feedback. So these are very much essential. Okay. So the third important point, okay, a design engineer should have for designing any particular system is consistency. Okay. So it says user should not have a learned, okay, different rules from different parts of the system. So it should be very consistent. And of course, the feedback and visibility are another important points that a particular designer should take into consideration. So it's like allow users to customize their own experience. So supposing if you design or if you are using a particular website, you should provide a particular box or a way how that particular design was, whether it is good, whether it is appealing, how many stars we give. Okay, so these are all some of the flexibilities and say for example efficiencies and visibility a particular designer should focus with. Okay, so the another thing is error prevention handling. That is very, very important. Okay, so error prevention and handling is another important thing that one particular person have to take into consideration. Okay, so okay. So there are certain golden rules and heuristics for this particular human-computer interface. So that particular golden rules are given by Schneider's 8 golden rules. Okay, so these golden rules are going to give an enormous amount of information how a particular design can be very, very easy. Okay, so the first thing is strive for consistency. So what is that strive for consistency? For example, so the design what that particular expert have to do is to have a good layout. Okay, so the terminologies has to be very well defined, and the command buttons which are used in particular interfaces ought to be good. Okay, the second thing is like enable frequent uses. So now whenever a particular design is made and it is being kept in the market, we have to be very sure that that particular design have to go into the market and it should be used. Okay, so how we will account that? For example, we have a lot of machine learning algorithms. Our experts have discussed last 5 days to find the accountability. Okay, for example, how many users have used this particular website? We should have a count. So that particular count will make us design that particular website more better and better. Okay, so it's like that. And the third important thing is offer informative feedback. So this what this point I discussed now is another one. Supposing if we get a feedback from a particular person or the many persons who are using that particular websites, so based on that, an improvement of that particular design can be always made. Okay, so offer informative feedback for every user action at a level appropriate to the magnitude of that particular action. Okay, so the next one is design dialogues. Okay, now whenever we design a particular interface, so it should be interfaced, it should be like an interactive one. Supposing if it is very stationary, when it has to move to the next slide, next design, next, if it is not interactive, then that particular design will not go correctly. So that won't happen properly. So we should have a particular usage properly, so that a dialogue should happen between the user and that particular design. Such a kind of a rule is very much emphasized for human-computer interfaces. And the next is very important. So whenever a particular design is made, there should be the different ways that in that error prevention should be made very clear. Okay, it's like, so the error prevention, simple error handling mechanism should be there. For example, we often see, for example, when there is an update, okay, so they should not allow the website to be alive. Okay, so they should not maybe like they should not allow that particular website to get interacted. So they should go offline, something like that. Okay, so okay, so they should not allow that particular what you call like the user, okay, so to go for a much error. So the error prevention should be there. Okay, the next one is they should permit easy reversal. Now, for example, when there is a website, just imagine there is a website where payments are made. All right. Supposing for some reason a particular design is made where we started giving some information and we have gone to the next slide or the next page. But for some reason, supposing if there is a mistake made by the user and if he is coming back, we should not design a particular website or a design where an error should be thrown. Okay, it should be like that particular design has to keep back the static information which is present in the earlier page, and it should be alive. Okay, so that is called reversing. For example, when there are some 4 pages available, when a user is moving from the 3rd page to 4th page, so they should allow that particular user to reverse back from 4th to 3rd without any hassle. Supposing if the design is not made properly, supposing if it is coming back from 4th to 3rd, and if it throws that particular error, then it won't be correct. Okay, so that is another thing. And the next 2 things are something like support internal locus of the control. Okay, so it says supposing support internal locus of the control so that the user is always in the control of the system. Okay, so whatever actions he performs on that particular design, so he should have that particular control. Okay, so like that. So the last one is reduce short-term memory load. Okay, now we have to understand this technically. Supposing if there are some series of actions on a particular design, when a particular data or a huge data is present in the memory for the next transaction, then that design is not going to be good because the RAM is getting used in a high way. So we have to make a design in such a way that the short-term memory, which is being processed for the next page or subsequent page, should be always less. So these underlying principles are nothing but the golden rules for heuristics. Okay, so if these 8 golden rules are followed properly, you can have a better design. Okay, so better interface designs can be prepared. So and next, coming to the importance. Okay, so the importance of human computer interface in the modern technology. Okay, so there are a few things that we need to discuss before we go for the actual applications. So I wanted to discuss some of the modern applications where that the human computer interface are being done. For example, how avatar conferences are done and how it is being implied with the modern day medical healthcare divisions. So many things. I have that slide to discuss with. Before that, I just wanted to complete this importance of the human computer interface in the modern technology. The first thing is it enhances usability and user experience. For example, a particular design which is made with a perfection, it ensures the technology in intuitive way. Okay, so with the utmost technology, and it is very efficient and it is easy to use and improving with the user satisfaction. That is the first main importance of any HCI. The second one, so it increases productivity. For example, supposing if a particular design is made, so that design is used by a particular expert in a particular company, so the company will always look for a better profit, okay, from that particular engineer or a planning engineer, etc., etc. So that we will be using that particular design so that the productivity should go high. Okay, so the platform should be made in such a way that the particular productivity is going higher and higher. Okay, so the next one is it should go for the improvement in the accessibility. Okay, so HCI always promotes inclusively by designing interfaces suitable for people with disabilities. Okay, so for example, screen readers are there, voice commands are there. So such a kind of things are to be included. Say, for example, we use some modern day websites where multiple kinds of interactions are made, not only text. Supposing if you are not able to type, for example, there are certain AI tools like voice commands. Okay, so what is discussed here is we have to design in such a way that those commands like receiving voice commands and doing things for you. For example, gesture. For example, if I move my hand, okay, based on this particular gesture, some action have to be taken. So these kind of designs will improve that accessibility. Okay, so these are all something which is going to support your technological advancement. So simple designs will not work out in the present day scenario. A design should have, say, for example, AI enabled, for example, voice recognition system, gesture recognition system, eye blinking system. So many things are there. As a whole, we can see, for example, your design should always go for reduction of the error, okay? And it should enhance safetyness. For example, what is like safetyness? So it's like a properly designed system minimize human errors in critical fields like a healthcare. For example, we have plenty of design work that is going for a healthcare division. Just imagine if there is a wrong input given in a particular design, and that particular design interfaces with another design which is being used by, for example, a practitioner or a clinical physician, where he is going to give a command like you change this particular medicine, you change the amount of injection level, etc., etc. It is going to be a very harmful thing. So you have to be very careful in making that particular design such that these errors are reduced and it enhances the safety. Because we can see the entire hospital administration, for example, I'm telling you, it is with this kind of a human computer interfaces only. Too many humans are not directly getting into the field. Okay, so many computer designs are involved in that. Okay, so the last two things like it facilitates better communication, drives business success, etc., etc. So these are some of the importance. Okay, so now before coming to the first part of my presentation, let us discuss something about what are the different components of this HCI. One is like a hardware, another is software, and the next two things are very, very important. Like one is cognition. Okay, so one is cognition and another one is ergonomics. So now let us not discuss too much about the hardware and software. So let us go with the human factors. Okay, so cognition and for example, this one, for example, ergonomics. Okay, so cognition, when we discuss about it, it's like supposing every person, see, the design of any particular system should be made in such a way that it is going to be a compensative design where everybody can use, because cognitively everybody are not going to have the same cognition thinking. Okay, so our design perspective also should be, taken into account for cognitions. Okay, what are the key cognitive aspects? Okay, what are the key cognitive aspects in a human computer interface? It's like the first thing is perception. Okay, perception is so how users quickly recognize visual elements. For example, when we operate with some tools, modern tools like, for example, let me tell MS Word, for example. So it is such an appealing tool where the icons, okay, so the buttons, for example, the different color codes, etc., present on the icons, menus, sub-menus are very clear. So that increases the perception of a particular user. That is what I defined here. So your design, for example, when a particular person is designing a tool like MS Word, okay, how carefully that particular perception is made. Okay, so you can see each and every tool or each and every icon or each and every menu or sub-menu are done with such amount of care that a perception holds very nicely. Okay, so some examples, let me tell, for example, how we prepare the icon, how we prepare the buttons, command buttons, how color codings are made on each particular menu. Okay, so such things are something like perception. And when we discuss about the memory, okay, so interfaces should minimize reliance on memory providing clear navigation. See, what is the main key idea is when we use a particular design, the designer should not compel us to keep things in our mind. For example, let me tell one example. We often encounter with some kind of a websites where our username and password are to be kept. Anyway, password we need to remember, and we have some like a captcha or something like that. But if the particular designer gives a compelling note that here you have to remember more than one or two passwords, then it become a hassle. Okay, so what the particular design has to do is, anyway, for password we need to have for our privacy, okay, protection. Too much memory load from us should not be taken into consideration for a particular design. Okay, so interface should minimize the reliance on the memory, providing a clear navigation. That has to go for the next. Okay, so the next point a particular designer has to keep a clear cut thing is like attention. Okay, so on what particular task, that task button should be enabled. Okay, should be embedded. Supposing if a particular field is not being filled up, okay, you should not allow the designer to give OK button or a submit button, etc. So that kind of attention seeking design aspect have to be considered. So that is one kind that particular cognition thing have to come into play. And the next thing is learning and problem solving. So these are very important thing that one particular person have to think about. Okay, so human computer interface should facilitate easy learning, okay, through the particular layout that is being designed and learn through some feedback mechanisms. Okay, so the next one is cognitive load. Okay, so now as I discussed earlier, so your design should always minimize, for example, that particular mental effort a particular user will give from his side. Often when he moves from one particular page to another particular page, then it is not going to be of great things. Okay, so the next important thing a particular designer has to think about is ergonomics. Now, what is ergonomics? Supposing if you design, for example, a laptop, okay, the screen. So that particular laptop screen should be, for example, kept approximately 30 to 35 centimeters away from the human eye. That is one of the ergonomics, because normally we see our human eye perception is like we can see clearly a particular letter or a font or a particular figure when it is kept approximately from 30 to 35 centimeters. So that is one of the key ergonomics. Just imagine I'm just making a laptop where that particular screen is kept 50 centimeters away, then I will not be able to work properly. Okay, so this is called physical ergonomics. There are plenty of things that ergonomics point can be discussed with. For example, supposing if I'm making a particular layout of the design where that is kept down in that particular layout, means I will not be able to read properly. It should be kept where that particular readability is more. So these things are very important. Ergonomics is like making that particular user convenient to go with that particular design. That is called ergonomics. So a designer who is going for this kind of a human computer interface should be keen enough to go for physical ergonomics activity also. Okay. The next important thing a particular designer should go with is called the interface designs. Okay. So that's like a screen readability. Okay. So the screen readability should be very, very clear. Okay. It should be like a focus. So it should not strain your eyes. It should not strain your neck, something like that. So your design should fall like that. Okay. Supposing if a particular design is open and it should cover the entire particular screen. And if it is focusing to right, left, or right top corner, etc., it is not going to be such a fair, optimal design. And then next one is posture and interaction comfort. So that, as I told, supposing when we design a particular keyboard, just for example, the keyboard design is very, very important because without using the keyboard, we don't have any prompting system, or we don't have any PC system or any other system. Okay, so the designing a keyboard is one of the universal system, or it's like a universal comfort computer interface system. It should be done so carefully that every human being with a kind of a common kind of a architecture in the hands should be able to use it properly. So those things comes under posture and interaction comfort. Okay. The next last one is haptic feedback and touch sensitivity. For example, we design so many interfaces. One thing is like we often have a laptop where it recognizes our fingerprint. So that is also one of the touch sensitivity interface. Okay. So that should be made clearly that at least it should be usable or workable for about 4 to 5 years. So we can't have, or we can't design a particular touch sensitivity screen which is not going to work for more than 1 year, because the laptop what we use maybe like we will be using for some 3 to 4 years. All right, so that is not the correct thing. So haptic is the touch. Okay, so it is something connected with your for example, virtual reality, augmented reality. So such a kind of feedbacks are always kept for increasing ergonomics in your human computer interface. Okay, so there are list of evaluation methods when we prepare such a kind of a human computer interface systems. We have a lot of evaluation methods. Okay, so few methods are like heuristic and cognitive walkthrough, and GOMS like goals, operating methods, and selection rules. So many things are there. These are some of the HCI evaluation methods. Okay, and this is very, very important. Okay, so anyone who is into human computer interface should be able to understand what do you mean by Fitts law. Okay, so Fitts law, there is a very simple exercise. Okay, so this law says there is a small formula. Okay, for example, T is equal to A plus B log to the base 2 and D by W plus 1. Now, what this particular Fitts law says? So the Fitts law says, so for designing a particular keyboard, for example, or designing a particular screen where a cursor is there, where I need to point to a particular button, or if I wanted to click onto a particular menu, just imagine, I'm just giving a small example. When we use a paintbrush, for example, if I wanted to place a straight line onto the screen, so I will have a target. I will be holding my, for example, the mouse. I will be taking that particular mouse and dragging the cursor to that particular straight line. I will hold it. I will bring to that particular screen. I will drag it, etc., etc. This is what explained in this particular law. Okay, so the time required to reach the target. Supposing you have a cursor in the screen, and I will make that particular pointer go across that particular line, hold it. So that is the time required to reach that particular target. That is also calculated. And the distance to that particular target, for example, from that particular menu, where that straight line is present, I have to drag that particular straight line to the white screen. That is the distance. Okay. And what's the width of that particular target? And there are two constants. One is like an empirical constants based on the input device and that particular device. Okay. The system design. Okay. So with that, there will be a small calculation. Okay. So the law says the closer and larger target, the faster it can be reached. So what they are trying to say is, whenever you use a particular design, you make sure that particular cursor, for example, I'm telling the particular cursor, what you are going to use to capture a particular control, a particular, for example, a structure that should be closer enough. Okay. Also, you have to make that particular target little larger so that this action can be made little faster. And this is the law called Fitts law. And this Fitts law should be used for a better human-computer interface. Okay. So that is what they are trying to say for Fitts law. Okay. So there are plenty of applications with respect to the Fitts law. Okay. So the different designs with buttons. Okay. So the spacing of interactive elements and how well we can make that particular corners. Okay. So all these are some of the applications of the Fitts law. Okay. So these are some of the relevances that we need to have for the Fitts law. Okay, we have plenty of examples that we can tell about web and app design. I can tell you whatever designs that are done by Google are the very best examples for Fitts law. Okay, so touch screen design, we are making a lot of designs with the smartphones. Okay, so how well and how sensitive that particular screen should be, those designs are like coming under Fitts law only. Okay, so touch screen designs, and we have a lot of virtual reality and gaming applications. So such things are like very good examples for Fitts law. Okay, so we have plenty of medical imaging systems, and the last 2 days experts were telling about different MRI scans, how to reach that, how to rotate that. So all that are some way like related to Fitts law only. Okay, so there are certain limitations of Fitts law. Okay, so it does not consider cognitive load. Okay, and it is less applicable for non-pointing tasks. There may be some designs where the pointing is not required. Okay, so such a kind of things also may be there. Okay, so and there will be always a trade-off between accuracy and the speed. Okay, so these are there. And since this particular FTP is some way connected with the space navigation, and I have noted some of the areas where human-computer interfaces are mainly focused. One is it is getting a higher kind of intuitions with the astronaut and computer interactions, and the mission control and the remote operations with the spacecraft, and the navigation systems and automations, and the spacecraft and displays, UX designs. And there are several issues with the spacecraft navigations also. There are several challenges. One of the key challenges of space navigation's human-computer interface is like a latency use. Okay, it's like a delayed communication with Earth. Okay, so with user-friendly interfaces, because after certain layers of transmission, then this particular interface fails to receive the signal properly. So that challenge is always there with respect to space navigations, because there are certain constraints like zero gravity constraints. So it is not so easy to make an interface working with the space. Okay, so interfaces must be adaptable to different other layered environments. So with that constraints, designing a human-computer interface is not so easy. Okay, so the last thing is the human factors, cognitive load. So many things are there. Okay, so let me take a quick roll with the different applications. Okay, so these are some of the applications that I wanted to discuss with the participants today. Okay, so these are some of the very important latest HCI real-time applications. One is avatar conferences, how well we can make with human-computer interface. Next is cognitive models in human-computer interface, and how well we can use that in automotive interfaces and in emergency services. So many things are there. Let us go one by one. Okay, so I hope the screen is available now. Can anybody respond whether the screen is available? Hello? Whether the screen is visible? Can anybody answer me?
Yes, sir.
Okay, now let us go to the first kind of application. Okay, so let us go to the first kind of applications, like how well we can use human-computer interface with avatar conference, because now making a conference is so easy. Okay, how well or how appealing that particular conference should be. The one thing that has been used in the latest versions are called avatar conferences. So what is mean avatar conference? Okay, it is like a digital representation of the user in the virtual environment. We may not be present in that environment, but by using a human computer interface, we will make available, or we can make our own system possible with the intuition that we look like that. Okay, so the importance of virtual conferencing everybody understands. So it gives an enhanced interactions and the presence in the virtual meetings. So it gives an appeal that that particular person is available. Okay, so now you can see this one example. Supposing a person is available, okay, elsewhere, and if he wants to meet a particular person, maybe like in the US or UK, something like that, and he wants to explain his articulation with an expression, okay, so we can make hologram kind of a human computer interface interaction, and this will make a appealing. Okay, so for example, with this kind of a virtual meeting, what is emphasized means our presence will be emphasized, the information conveyed will be emphasized in a correct way, so it will be like more informative. Okay, so these are some of the highlighted applications which are presently dealt with human computer interface. Okay, so now when we talk about the real avatars, so what we can do with it. Okay, so one is like the key point what we need to do know is it is having high fidelity visuals, so it will go with the realistic textures, so we can choose a particular texture. With that we can combine our own facial textures. Okay, we can give our own expressions, so these kind of designs are very well possible with the human computer interface. Okay, also what are the other possibilities? Okay, so we can go for lifelike gestures, means we will be supposing I'm just, I mean, for me, okay, if my lifestyle gives a particular gesture, we can make this gesture available in that avatar. Okay, our own body movement, so that a person present elsewhere in a different country will feel like he is really talking to me, because he knows me earlier, he knows me how my body movements will be available. Okay, so he will make that particular thing in a realistic way. Okay, he will feel that as like I am there in that particular conference. So these things are possible with the real avatar conferences. Okay. Also, the voice that I speak, okay, we can inculcate with the voice recognition system. The same kind of a voice will be made available during the conference. So that is called natural voice synchronization system. So that is possibility. That possibility is there. So now it's all with a human-centered design. Okay, so with a different usability and feedback and adaptation. Okay, so what are the different principles of avatar design for virtual conferencing? The one thing that we have to go with it is realism. Okay, so what is that realism? When we design that avatar conference, or when we design that human-computer interface for avatar conferencing, we have to make a balance between that hyper realism and functional design to avoid uncanny valley effects. Means it should not have a blurry effect over that particular hologram. Okay, so some references I have given, maybe it is useful. Okay, when you have to know more details about this kind of impact of human avatar interaction, okay, you can refer to this particular paper. Okay, so another thing, okay, so this particular picture, it shows the effect of hypothesized emotional response of subjects. Okay, it is plotted for a particular uncanny valley. Okay, so when a humanoid robot is giving that kind of a realistic conferences. Okay, so the other principles of avatar designs are like a context awareness. Okay, adapting avatar appearances and behavior based on the virtual environment. Another thing is inclusivity. Okay, what do you mean inclusivity? For example, when we go for a particular conference, the conference should be two-way. Okay, we have to include the participants into the conference. That is called inclusiveness. So we can do this kind of inclusiveness very well with the human computer interface. It's like customizable features to represent a diverse population. Okay, for example, one American speaking to an Australian, Australian speaking to an African, African speaking to an Asian, like that. We can have the different skin tones. Okay, so these designs are possible. Okay, the different clothing. So these are all possible. Okay, for example, if we need to have a virtual conference with a person who is present in Jaipur, we can make that particular person with a Jaipur conventional dress. So he will give an appealing that he is talking from Jaipur. Okay, it's like that. Okay, so some technological notes behind avatar. Okay, the first thing that technological thing that we have to consider for making this kind of a avatar conference is, the first one is motion capture. Okay, short it is MOCAP. Okay, so it should use or the capture the movements and replicates them in avatar. So what we need to do is, so as a person, if we have a common movement that we make, we have to make movement 1 to movement n, and that movement should be inculcated on that particular avatar. Okay, so I have kept the references also where I took from. Okay, maybe the participants can, if you are interested, you can just go through this particular paper and understand how our movement can be inculcated with avatar. Okay, so it is this particular paper is been published in 2020. And another thing is, one very important paper which discusses something more about avatar conferences is enhance that AI and machine learning kind of a topic, where it details about how the gesture is enhanced. Okay, how facial expressions can be notified, and how modulations of the voices can be manipulated with the virtual avatars. Okay, so these technical details are given in this paper. Okay, AI-driven emotional expressions in virtual avatars. This particular paper is released in 2019. Okay, and the rendering. Okay, so it is very, very important, like a gesture rendering. Okay, so by rendering, what can happen? Like provides more smooth and lifelike experience. Okay, so we can have the feel of haptic touch. Okay, something. And what technology is not still to go with is like smelling. So that particular part is still in research. So we have haptic, we have sensation, we have feel like touch, everything is possible, but the smelling kind of a conferencing is not possible till now. Okay, so this is there. And this current applications with the avatar conferences, no, supposing I am talking, for example, the same conference, supposing if you don't feel to see my face for a long time, I can make my face into some kind of a real-time avatar or something like that. Okay, so that is possible with Zoom integrated avatar feature, something like that is possible. Okay, so some other examples where our virtual reality is going, like horizon workrooms utilizing avatars, that is also presently available. So these are some of the current applications of looking real avatars. Okay, so these real-time avatars are also very much used in education remote learning. Okay, I have given some references for that also. Okay, and despite all that, we have some design challenges. So there is no doubt we have some design challenges for making this avatar come into play. Okay, okay, how you can overcome that uncanny valley, how that blurring effect can be removed. So that is one of the key aspect that to be considered. And another is very high memory location required, high computational requirements. Okay, so the hardware GPU should be very high. Okay, so we can't do it with a simple CPU system. We should have a multiple graphical systems. Okay, so that is very much required for realizing, okay, the rendering. Okay, so without any kind of a delay, if we need to make that kind of avatar conferencing, we need to have a high computational requirements. That is one of the second drawback I can say. And another thing is privacy concern. For example, once we market ourselves into this kind of avatar conference, the privacy becomes very low. This video can be captured and used elsewhere for some kind of intrusion effects. Okay, so it's like sensitive user data. Okay, like a facial features or movements that could be risky, because one can easily follow the hand gestures of a particular person and take some input from them also. Okay, supposing just imagine from that hand gesture, one can take the fingerprint also. That possibility is there. Okay, so these are all some of the privacy concerns one should know for making this kind of a human-computer interface. And the last one is like accessibility. So it requires access to high-tech equipment which may not be available at all places. Maybe in the transmitter side it is available, but in the receiver side it is not available. So, okay. So some of the future trends in how that particular avatar design. Okay. So we will have a lot of AI capabilities. Okay. So now with that AI capabilities, we can capture the facial expressions very clearly with a high dimension. Okay. And we can also go for high emotional responses. Okay. So that possibility is there. And integration with augmented reality and virtual reality. Okay. So virtual reality is a subcomponent of augmented reality. Okay. So that is also possible. Okay. So the aspect is like a blurring the line between physical and virtual spaces. So we almost close to being in reality. Okay. So the next one is wider adoption. Okay. The lower cost and technological advancement make it accessible to more users. See, what is not accessible now in 2024, maybe, okay, 2025, may be very much possible after some 2 years. Okay. So now this is the aspect, wider adoption. Possibly when, for example, smartphones came before some 7 8 years with the wider applications. Now we can see almost every Indian, okay, who is aged above 18 or 19 owns a particular smartphones like that. These avatar conferences and these kind of designs will be available to everybody, maybe after some 4 to 5 years of time. Okay. The last one is emotionally intelligent avatars. Okay. Like AI-driven emotional intelligence that we can use it. Okay. So some of the research papers also it is there. I will make this particular PPT available with the FTP coordinator. Maybe interested people can use it later. And let us go for the next one, cognitive models and automotive interfaces, etc. So let me go for automated interfaces. Okay. So it is a very important thing, particular user should know. Okay. For example, in automotive locomotives, how human computer interfaces is of high use. For example, just imagine, okay, I'm going in a driverless car. So it is going by its own. So we know all the utilities. By hearing, we understand that, for example, Tesla car, it's like a driverless car. And we have the driverless system to drive that particular car. For some instance, okay, for some instance, something wrong goes with, okay, and there some human intervention is required. At that particular point of time, supposing just imagine you are not available. So you can make an interface where sitting from the home, you will be able to control that particular system. Okay. So such a kind of a thing is like human computer interface with automated interfaces, enhancing safety and comfort in modern vehicles. So I have certain important things that we have to see. Okay. So what are the key benefits for a safety and comfort? How that can be inculcated with human computer interface. The first thing is safety enhancement. Okay, like reduce, like your design should be in such a way that it reduces distractions and improve focus on driving. Okay, now let me tell one real-time example. Now, supposing if you take a latest Honda cars, okay, Japanese Honda cars, they have made in such a way that supposing if on a sleepy mode, when you are passing from one lane to another lane, it compels us, the system compels us to, it gives an indication to the driver to stick onto the same lane. Okay, it's like that. Okay, so it is one kind of a human interface application what we practice now, what we use it in the present day cars. Okay, they call it as ADAS or something like that. So this is one of the good example for computer interface in the automobile, which reduces distractions. For example, another one, let me tell you. For example, on a continuous basis, the eye movement of that particular driver is kept on monitored. Supposing just imagine if that system senses that the driver is going to the sleepy mode, it will give an alarm, or the system will be having a design to give a alarm to your mobile phone or a call systems, etc., etc. So these things are some of the examples of automotive human-computer interface where it reduces distractions and where it can improve focus on the driving, etc., etc. Okay, so let me not go into deep into that. Yes, and it is fully functional now. For example, Tesla car. Okay, it is totally AI-driven interface car. Okay, it is fully autonomous driving interaction. So that is one of the principal automotive example what you can reflect back with the human-computer interface. Okay, so we can say, for example, very rarely we understand that there are some incidences happening with the Tesla cars. So it confirms that it goes with the increased road safety, more comfortable travel experience, enhanced passenger interactions. Okay, so in that, so many interfaces are there where the passenger can interact with the system, okay, etc., etc. Okay, so now basically what we can conclude is like this human computer interface in cars particularly will continue to evolve. There is no end. Okay, so a lot of things will come, making vehicles very safer and more user friendly. Okay, so there are a lot of things that we can discuss with it, like a touch screen, how it functions. Okay, voice controls, particularly in automotive car systems, gesture recognition. I was telling about one important thing. Supposing on a night, okay, a driver is driving a particular car from uh, one state of US to another state of US, and there will be a continuous eye tracking system which monitors the eye movement of the driver in case if it goes slided down like a sleepy mode, etc., etc. So it automatically halts the car without driving. So this comes under gesture recognition. Okay, it's like uses, okay, it uses a lot of IoT systems. Okay, it uses plenty of sensors, it uses plenty of actuators. Okay, so it can get connected with the cloud, and the cloud infrastructure will keep reminding list of data to the monitor systems where the drivers are sleeping, etc., etc. So many things are possible now with the gesture recognition. Okay, and one important thing that I downloaded for today's presentation is that latest BMW car with the iDrive system. Okay, so it is fully automated. Okay, BMW iDrive cars are fully automated with a fantastic human computer interaction automotive. Okay, so what are the best things that present in iDrive in BMW? Let us see a few things. Okay, so we can say iDrive systems in BMW is like a cutting edge in car infotainment. Okay, and it controls very clearly the interface designed to centralize and simplify vehicle operations to the extent of road safety. Okay, gesture control and everything, and offers control over navigation. Okay, it is fully GPS navigated and even C navigated, everything. Okay, media and vehicle settings. So the complete domination is there by BMW iDrive systems. Okay, so the key objectives, okay, for this kind of iDrive are like it enhances user interactions through intuitive designs. Okay, it reduces distraction by streamlining the controls present in the car, and it improves safety and convenience with the hands-free and adaptive features. Now we can see slowly that hands-free kind of a movements are coming in the car, like a rendering, like a finger rendering. So just by basically movement of that particular hand gestures, etc., etc., we will be able to rotate the what you call steering of the car, etc., etc. Okay, like these are all called hands-free adaptive features. It is available with the iDrive BMW. Okay, and some of the key features that the human computer interface is used with BMW iDrive is, the first thing is a touchscreen display. Okay, so there will be a central display. It provides easy access to the different navigation, mapping, okay, G mapping, etc., and all the entertainment facilities and the vehicle settings with a user-friendly interface. So that is there. And another thing is rotatory controller, like for example, even the volume control, or for example, wherever knobs are there, okay, AC control or AC vent control or anything, whatever may be. Okay, so a physical knob, okay, near anywhere, so that can be controlled with your hand gesture itself. Okay, so without reaching to that particular knob physically, okay, you can do that with the system, with the interface itself. So that is possible. And another key features with the BMW iDrive is totally it is voice control. You can control your entire car system, okay, including your driving, including your control of the speed, okay, lighting, illumination, fog control, everything, okay. So every particular control of your BMW iDrive you can enable, okay. It's like through voice controls, okay. So it enables drivers to access features like navigation, music, okay. It's totally hands-free, okay. So that is there, and there are plenty of benefits, okay, with this kind of a, even though it is cost effect is more, okay. So such a kind of a car with a high-end human computer interface iDrive system, even though the cost is very more, there are the key safety benefits. One is reduced distractions, okay. So with the different possible voice and gesture controls, okay, minimize the physical interactions, okay. So that helps that particular driver to stay focused during the driving period, okay. And another one is very efficient navigation, okay. So real-time maps are available, and traffic data, so it keeps updating, it's not static, it is going to be dynamic. So your BMW iDrive is mapped with your real-time traffic data all through the globe, okay. So it is automatically mapped with the traffic data, okay, and it will give an updated optimal planned route to the user. So you can switch between the different lanes, different routes for an optimal reach, okay, quick reach, okay. So, and avoid obstacles without diverting any attention. That is another safety. And under convenience, there are two things. One is personalization. Okay, so particularly this BMW iDrive car, so it saves driver profiles. Okay, and you can totally adjust the seats just by hand gestures, and you can adjust the mirrors, and you can also adapt to the screens. Okay, based on the climatic conditions, whether it is very too sunny, you can make this particular mirror with some kind of a dimness, okay. So chromatic level adjustment is possible with the BMW iDrive. Supposing, just imagine you are driving this car with a high humidity or a high intensity of sunlight, so you can make that chromatic level come down so that you will not get the glaring effect, okay. So that is possible with the BMW iDrive. So another one is some integrated controls are there. Okay, so different navigations can be combined, and vehicle settings are possible. Okay, and multiple button adjustments are possible. Okay, so these are all some of the benefits with BMW iDrive, which is using that human computer interface. Okay, now looking ahead, okay, what are the conclusion points that we can discuss with this kind of application? So now this iDrive continues to innovate with AI-driven predictions. For example, some predictions and other analysis keep updating to the driver or even the driverless car, making whether to go in this particular lane or whether to follow this particular road further or not. Okay, these kind of things are now inculcated with BMW iDrive. Okay, so it has got a particular future for this intuitive way of understanding the prediction of traffic and other issues. Okay, so we can understand one thing. The best example, like HCI-based BMW iDrive cars, focused approach is a model how car interface can prioritize driver focus and comfort while incorporating advanced technology. Okay, so that is one very good example. Okay, this I can say. Okay, so BMW iDrive car is one of the very best example of the advanced human computer interface in automobile section. Okay, so let me go through some more things, like there are many things that we can discuss. Yes, another is retail and e-commerce. Yes, yes, see, there are plenty of applications we can discuss with the human computer interface. We discussed one thing with automobile. one thing with the real conferencing avatars. Similar way, we can discuss this also. See, without commerce, the world is not going to exist. We can prepare fantastic human-computer interface with the retail and the commerce departments. Okay, this kind of areas. Now, you see how people can make the design so intuitive and interactive so that we can develop our commerce by ourselves. For example, we have mutual funds. For example, plenty of designs are available for different mutual funds. Now, without we making a special effort, now we have AI assistants which pop-ups and gives on a daily basis whether this particular fund, what you keep it in that particular company profile is going to be useful or not. That is one of the key findings of the present day human-computer interaction in terms of e-commerce. Okay, so it is very, very important. So such a kind of a design should be there. Okay, so for example, how it increases the overall business. So third point is there. Just to see, the e-commerce market is rapidly growing, particularly with this kind of a enhanced human-computer interface, with the global sales surpassing 4.9 trillion in 2021, and it is almost 3 times when compared to 2021 in the present day scenario. Okay, so we can understand the importance of human-computer interface in the field of commerce. Okay, e-commerce have grown excellently while using human-computer interface. That is what we have to understand. There are plenty of design rules. Basically, when we go for e-commerce kind of a design, okay, so when we are doing any kind of a design with the e-commerce, so usability principles should be taken into account on a high priority. Okay, so there are certain examples or case studies that we can discuss. For example, major platforms like Amazon, for example, employ these design rules using simple layouts, clear navigation, and recognizable icons that make the shopping experience easy and enjoyable for users. Okay, why I kept this second point for the participants today is when we design a particular design, if we don't make it very, very simple, users will not continue using. But at the same time, the key design principles of HCA should be followed. One of that is, say, for example, Fitts law, or one of that is heuristic law, so many things. But if you follow the design and if you make that particular design very simple and intuitive and interactive, your business will definitely increase. And one of the very good example, what we experience is Amazon. Just imagine we keep using that Amazon platform for buying products, buying whatever it is. It is not a single kind of a platform where it is used only for getting that things. Okay, it has gone to the extent of even IoT applications. Okay, all kind of IoT applications. So such a kind of a rise that we can see it in this kind of a company. Okay, so when we properly follow the design rules and develop a system, we can definitely win in e-commerce. That is what the idea is. Okay, so now another important thing is the layout with which you are making that particular e-commerce design should be very, very appealing. Okay, the screen layout or the layout in the e-commerce refer to the strategic placement of visual elements. So now when a particular e-commerce design is made, so we keep putting a lot of things into the particular design. So it should be very, very interactive. Okay, on each particular design control, a link should be made. Okay, so when we make such a kind of a design, then we will be able to easily make that particular design win in the market. Okay, so these are all some of the points I wanted to discuss. All right. So something is called universal design. What is that universal design? For example, when we prepare a particular design, okay, in e-commerce particularly, that particular design need not stick onto a particular state, need not stick onto a particular country or a continent. It should be globally used. Supposing if a particular design is used across the globe, not only a country, not only a continent, not only a state or a district, then it is called a universal design. So in particular, electronic commerce is across the globe. When we make a particular design, we have to make sure that the design is universal. Okay, so then that particular principal design will keep working and you can have a fantastic upgrade in your design. So I'm just taking some important points that I can discuss. Yes. Now, this is another important point a particular participant should understand. Now, when you make such a kind of a e-commerce evaluation design, you have to make this particular point into high consideration. So you have to make user participation available here. Okay. For example, when we don't take user participation in any particular design, then you can't take the actual feedback and you can't increase the design capability. Okay. So in any user-centric design, gathering feedback from the actual user who is using that particular design. For example, if you are using State Bank of India like an online payment methodology, so you have to take a user feedback. So that user feedback will be able to be useful for you to improve that particular design. You can't take a feedback from any person who is not using. That is not user-centric. Okay, so one example I have kept here. You see here, Amazon Prime Videos uses feedback from the users to make the layout change, okay, that enhance the content discovery time to time. Just imagine how far that particular company has grown. Okay, so now the third point is kept for your clarity. Products developed with the direct user input feedbacks tend to achieve 25% higher satisfaction. For example, when we are running a hotel business, we have to make a kind of a design where the user will give the feedback right away after their dining. Then the design will win. Okay, it can be used for your business perspective. Okay, so many things that I have kept for your understanding. Let me see other important points that I can discuss. Okay, so let me tell this particular point as the final point for your e-commerce. Okay, the future of human-computer interface in retail and e-commerce. The future of HCI in e-commerce includes trends like AI-driven personalization, augmented reality for virtual try-ons, voice commerce. That is coming up. E-commerce is now little bit gone away. Voice commerce have come into existence. Just by giving our voice commands, that voice command will be recognized and the system will understand whether that particular user is a legitimate user, and then we will go for the commerce, means buying the product, selling the product, etc., etc. So such a kind of a commerce is called voice commerce. So now in last 2024, this voice commerce have come into existence. Okay, so that is in the play now. Okay, so like for example, I kept one more point. Innovations like Amazon Alexa voice, shopping features, augmented reality based product previews. So many things are there. Okay, so that is also possible. Okay, so these are some of the features of human computer interface in the retail and e-commerce. Okay, so let me tell one more example. Okay, yes, where human computer interface can be used in some emergency situations. Just imagine we are in a place where some fire accidents happen. Okay, so supposing if the fire accident is there and humans cannot enter into that particular place and they can't detect what is happening inside, so you can have a design maybe like a camera system, and you can make that particular camera system to fly into that particular place. Okay, maybe like a fire will not be able to harm that particular camera systems molded with some kind of a insulation material, etc. But we can't go inside, and it can capture the data for you, and it can send the data where we can make some people available for rescue. So such a kind of a thing is called emergency services. So in emergency services, human computer interface designs are high use now. Okay, so I have kept some slides to discuss on that. Just see this. Okay, so human computer interface is the interaction between humans and computers to accomplish a task, etc. So let us focus on this one. Okay, so on emergency critical systems. Okay, so for example, why human computer interface matters in critical systems? Okay, for example, it requires high stakes decision making under pressure. One example is what I told, in a fire accident system or in a place where fire accident have really happened. So you need to make a key need. Okay, so that design can be done by human computer interface. Okay, so I have made some slides for that also. Yes, yes. How that particular system should be developed. Okay, so you should have an interface design for a high stress conditions. Okay, maybe like a pit, maybe like a fire accident, maybe like something where humans cannot directly intervene. Okay, so the must function in a chaotic, high pressure environments. What are the key features that you should follow to design such a system? Okay, so it should be very simple and it should be uncluttered design to reduce cognitive load. Okay, and you should have a color coded alerts. For example, highlighting urgent task. Supposing if there is a red indicator, you can make a red indicator glow when there is a high indicative system. Okay, so like a minimized click with some small button flows or button clicks, so the entire system should work. So these are the key features which are essential for designing an interface with a high stress conditions. Okay, and your design should access some real-time informations. Okay, so it should be real-time access as well as adaptive. So what is real-time access? So your design should give providing responders with up-to-date data such as weather, location, team status, everything. Okay. For example, just imagine in a mining system in Indonesia, this particular system is used. Where in the deep mining system, how many peoples are available? What are the weather conditions? Okay. What is the state of the human peoples present in that mine? Everything this kind of a systems will notify. Okay, so there are some gold mines present in Africa where the weather conditions inside that particular mine is too extremely hot. Okay, even though the humans who are working in that particular mines are given with some aprons, their health condition should be monitored. So such a kind of a details are available with this kind of a system. Okay, so we have that kind of a responders who give, okay, the system which gives the real-time data as and when required. Okay, and also it should be adaptive. Okay, so it should adjust interface layout based on the severity of the situations. Okay, so as I told, this can be used in gold mines in Africa, something like that, some coal mines in Indonesia. So those people are using this system in real time. Okay, so it should have a priority information dynamically. Okay, so based on that, we can go for some kind of a resolutions. Okay, so you can have an integrations with the human assistants. Okay, so you can have this particular system with a integration. So you can inculcate artificial intelligence, which can assist in predicting outcomes and help with some kind of a decision making for this particular scenarios. Okay, so real world examples. So like that, what I wanted to tell in this particular thing is like we have plenty of applications, real time applications where human computer interface is happening in the present day scenario. And I have just indicated some 4 to 5 applications only. I have with me near about some 20 applications which are currently used in gold mines, which are used in coal mines, etc., etc. Okay, so so there are plenty of other applications too, which I may not be able to tell during this particular session because there is a time constraint. Okay, so let me, yeah. So let me have a thanking note to all the participants and the FTP coordinators for giving me an opportunity to discuss on various design aspects of human-computer interface. And let me open this 5-minute session for the participants to discuss with me regarding human-computer interface and design aspects. Okay, in case if they wanted to have a design, some kind of a discussion to be made, I welcome participants to do that now. Am I audible?
Yes, sir.
Yeah. So,
Thank you so much, sir, for your presentation.
thank you, ma'am.
1 minute, sir.
Participants, any question? Good evening, everyone. As we come to the end of today's first section, I would like to express my sincere gratitude to all those who contributed to making this session a great success. First and foremost, a sincere thanks to our esteemed resource person, Dr. R. Vijaya Arjunan, for delivering such an engaging and informative session. Your deep insights into the topic impact of human-computer interface have truly enlightened us, and we appreciate the time and effort you took to share your knowledge with us, sir. Next, I would like to extend my gratitude to all the participants for your active engagement. Once again, thank you all for making this session a great success.
Thank you,
Now,
ma'am.
I would like to hand over the session to Mrs. C. Chenisha, Assistant Professor, Department of EEE, Macet.
Good evening to all. On behalf of Marthandam College of Engineering and Technology, a very warm welcome to our resource person, coordinators, and all the participants of Atal Fdp on emerging trends in space and computing technologies. It's my great pleasure to welcome and introduce our esteemed resource person, Ms. Snita Shetty, Assistant Professor, Department of Computer Science and Engineering, AG Institute of Engineering and Technology for this session. She is currently pursuing PhD at Visvesvaraya Technological University. She completed her master's degree in engineering in 2014 and bachelor's degree in 2012. She is an assistant professor in the Department of Computer Science and Engineering at AG Institute of Engineering and Technology. With over a decade of experience in teaching and research, she is committed to fostering the development of future engineers. She had actively contributed to academic research, presenting 10 papers in reputed journals. Her research areas focus on advanced computing technologies, NLP, and their applications. She has shown a strong commitment to student growth, guiding numerous students on their projects under UNATI, Karnataka State Council for Science and Technology program. Her mentorship has significantly impacted students' academic development and practical exposure to real-world engineering challenges. She had actively participated in and conducted several student development programs that focus on enhancing students' technical skills, creativity, and innovation. Once again, extend a warm welcome to resource person and all of the participants for this valuable learning experience. Now, I would like to hand over the session to our esteemed resource person, Ms. Shnita Shetty. Ma'am, please take over the session, ma'am.
Thank you, ma'am. Thank you, ma'am, for the introduction.
Thank you, ma'am.
Good afternoon, one and all. I'll be sharing the screen. The screen is visible.
Yes, ma'am.
Okay. So I'm here to talk about the data science and visualization. So I'll just brief out the objectives, what I'll be covering in this 1.5 hour. So I'll be talking about big data, data science, and data analytics. And I'll be telling the difference between these three and what is the role of big data professionals, data scientists, and data analysts in the business field. So first, we'll see what is data. So lots of data is being collected and warehoused. So day by day, we are dealing with the many data like scientific experiments, IoT data, web data, e-commerce, financial transactions, social network data, etc. Now, first and foremost, I'll be talking about the big data. What is big data? So the large amount of data from various sources. It means the different sources with a different formats, like it can be audio files, video files, JPEG, text files, and many more. So these data are unstructured data, and traditional data processing systems are incapable to deal with this large amount of data. So there is a big data professionals to handle this data with many advanced tools. So I can say it can be expressed in terms of volume, velocity, and variety. So there are a lot of big data advanced tools like Hadoop, SQL Mirror, etc. So now what is data science? So the data science, it's a multidisciplinary field with a goal to address the challenges in big data. So here you can see a diagram. So where I can say the data science contains a T with the different fields, like it contains the mathematicians, statisticians, machine learning domain, and traditional research and substantive expertise. And it is an area that manages, manipulates, expresses, and interprets the knowledge from the tremendous amount of data. So there are different techniques and theories from the different fields, and all these techniques and fields are needed to analyze this data science. So it mainly helps the decision makers in many industries to take a decisions in the field of science, engineering, economics, politics, finance, educations. So if I tell it's a computer science, again the computer science, the different fields like pattern recognitions, visualizations, data warehousing, high performance computing, database, AI. In the mathematics, again there are the different models like a probability models, statistical models, etc. So all these teams forms a data science. Again, I'll be coming back to the data science in detail. So before that, I'll be just explaining the what is the exactly role of big data professionals. In industry, the big data professionals, the data analyst, and data scientist, all three make a business success. So these three members, these three teams are required to take a decision in the business. So what is the role of big data professionals? So mainly these big data professionals, they architect the distributed system. So they will tell how to store the system and how to handle this unstructured data. So they build a large scale data processing system and they process the data using many tools, as I said, many big data tools, and they ensure that the network connectivity is active. The big data tools contains Hadoops, Storms, Rapid Mirror, and BigQuery, etc. So using these tools, so they make sure that the data is active and it is working. Whereas the data scientist, what is the role of data scientist? So the data scientist using many advanced algorithms like AI and machine learning algorithms, they predict the future based on the past pattern and using this, they will examine the data from the multiple sources and they will help the business to take decisions. And finally, they also finds the correlations and hidden patterns from the data. Next, I'll be talking what is the role of data analytics. Later, I'll be giving the exact difference between the data scientist and data analysis. So what is data analytics? The data analytics, they discover the useful information from the data and they support the decision making, and they also involve inspecting, cleansing, transforming, and modeling the data. They also use qualitative and quantitative techniques. So this is nothing but data analytics. I can say that data analytics is a subset of data science. So data analyst is a subset of data science. So what they will do in the business or in the industry is, so they acquire, analyze and process the data, and they find the insights. So they will find the meaning from the data, and they create the data reports using varieties of tools. Whereas, so, so these are the skill sets required for the data scientists, big data professionals, and the data analyst. So you can observe one thing here, that the skill set required for the data scientist and data analyst is almost same. The difference is the data scientist, as I said, the data analyst is a subset of data science. So the data scientist must be a good programmer. So nowadays, now the R programming, he must be expert in the Python or R code, and machine learning algorithms like advanced machine like deep learning principles, and he should have the depth knowledge of programming. There is a big data professionals, he must handle the unstructured data, and he must have the knowledge of multiple technologies like Hadoop, Spark, and Hive. So you might think now, what is it, when I explain this, so we feel both the data analyst and data scientist has the same role. But what is the exact difference between the data scientist and the data analyst is, I can explain this in a simple terms. The data analyst, they are the one who do day-to-day analysis, whereas the data scientist, so they think about the future. So they think, what is, if there is an information or a financial crisis, and what action to be taken in the future. So whereas the data analyst, they take the data from the single source, whereas the data scientist, so they take the data from the multiple sources. And the data analyst, they will solve the question, they will solve the business problem, whereas the data scientist, so they analyze the model, they will find the question, and they will formulate the questions, and also they help the business to take a decision. So this is the difference between the data analyst and data scientist. Since I'll be talking more about data science, so before going for the data science, we must know the difference between the data analysis and the data science. So I covered this. So let me take one real-time example, that is Netflix. So in the Netflix, what is the role of big data professionals? What's the role of data analyst? And what's the role of data scientist? So you can see the diagram here. The big data professionals, so what is their role? So they, as I said, so they mainly handle the unstructured data, and they mainly see how the data has to be stored. So here you can see here. So here in Netflix, a large amount of data is created, and the traditional data processing system cannot process this data. So what the big data professional will do is, so using advanced tool, so they will handle this data, and they will think about the storage and scalability of the data. So that is a main role of big data professionals. Whereas what the data scientist will do in this, the data scientist, they will understand how to optimize the Netflix streaming experience with the data science. So they mainly deal how to optimize the Netflix streaming experience. So what they will do is, they will understand the user behavior, like at what time the user has used the system, use an applications, and how long he was online, so how often he is using the applications. So they will understand the user behavior, and it is understanding how the user interacts with the network service. So the data scientists use this data to predict the user behavior. So the prediction, usually it is done using a bit rate or pre-buffer rate. So if the person is using a home network with a high bandwidth, then it will be having a high bit rate. So if he is using a bandwidth with a low bandwidth, then they will be having a low bit rate. So based on this, they will analyze the behavior of the user and they will predict whether the user will subscribe the application in the next month. Whereas what the data analyst will do here, the data analyst, since the applications, so the different people will be having the different choices. So this data analyst, what they will do is they will analyze each and every individual and they will help to build the recommendation system. So based on the user's choice, they will help to find the recommendation. So since to run any business, there are the role of three things, that is a data scientist, data analyst, and the big data professionals. So now I'll be moving to the exactly what is data science. So before that, I'll be telling the difference between the traditional analysis and the data sciences analysis. So in the traditional, they were using SAS, R, Excel, and SQL. Whereas in the data science, they're using the advanced like R, Java, scientific Python libraries, Excel, SQL, Hadoop. In the traditional analysis, there was a technique regressions, classifications. Now also they're using classifications, but there is a new topics, new advanced like a machine learning, that is a supervised, unsupervised, small and large scale computations. So here in the traditional analysis, the main role is a statistician, mathematician, and scientist. But as I said, data scientist means there's a role of mathematician, statisticians, developer, and the system engineers. So these are the difference between the traditional analysis and the data science. So now I'll be talking about the datafication. What is datafication? As I said, so the data science is mainly dealing with the data. So here, the main concept what we should know is about the datafication. So the datafication is nothing but it is taking all the aspects of life and turning them into data. Each individual is datified, knowingly or unknowingly, each individual is datified. So what is this datification? So for example, when we walk on the street, so our images are captured through the faces. That is nothing but datification. So for example, in the Facebook, when we give the like button, our data is datified. So in the Twitter, the thoughts are datified. So this is nothing but datification. So once we datify, so this information can be transformed into the values. So I can give some examples about the datification. For example, as I said in the Facebook, the likes, the Google augmented reality glass datify the guess, the Twitter, it datifies as plots, LinkedIn, where we give the professional information. So it will datify the professional networks. So this datifications, the data scientists they will use this datification, these data, and they will build the model to predict the future. So now, in the what you can see are many data science products in the we are using many data science products. For example, in the internet, we can see the Amazon recommendation system. So this Amazon recommendation system is nothing but a product developed by the data science team. Whereas the friend recommendation we are dealing with us, that is nothing but the friend recommendation system is built by the data science team. Whereas in the finance, we can see many credit ratings, trading algorithms, models. In educations, like many applications in the government, we can see the policies based data. So now, so what is data science job? A person who is expert in the computer science, the statistics, communications, data visualizations will get a data science job. So they form the data science. So nobody is expert in everything. So as I said, the data science team contains a people from the different fields, then they will build the model. So here, I now explain about the data science. So now I'm going to tell how exactly this data science process is followed. So what is a basic step in the data science? The main and the step of data science is EDA. That is nothing but exploratory data analysis. So EDA is a crucial and initial step in the data science project. So what is this EDA? So here I'll be talking about the starting step, the first and foremost step of data science process. So EDA is used by the data scientist to analyze and investigate the data sets and summarize the data and to build a data visualization methods. So it will handle the data, it will read the data, it will analyze the data, it will understand the data, it will identify the different patterns in the data, different variables in the data, and different relationship between the variables, and they will check whether the data is ready to process. So EDA is normally carried out as a preliminary step before undertaking extra formal statistical analysis. So since the future step of the data science will be building a model, so before building any model, each and every data has to be analyzed. So to analyze this data, we use exploratory data analysis. So the basic tool of EDA are plots, graph, and summary statistics. So generally speaking, it's a method of systematically going through the data and plotting the distribution of all the variables, like plotting time series of data, transforming the variables, and taking a relationship between the variables and plotting the matrices. So the main aim of EDA is to gain intuition about the data, to make comparison between the distributions, to find whether any variables or any data is missing, and to find the solution, how to find the missing data, to find upper boundary, lower boundary, outlier, and to summarize the data. So debugging is done. The EDA, the main step is, again, it is a debugging the process. So EDA helps us to make sure that product is performing as intended. As I said, the first and the basic step of data science process is exploratory data analysis. So if EDA output is success, then only we can move further. Then only we can build the model. Otherwise, again, go back, collect the missing data, so redefine the raw data, again, do the process. So this is what we are doing in EDA. So here you can see the block diagram showing the data science process. So this data science process, so this diagram exactly says how the data is processed. Okay, how the data science team will process the data. Whether the diagram is visible? Is it visible? Okay. So you can see the first step is the raw data is collected from the real world. The raw data is collected from the real world. Next, the data is processed and the data cleaning is done. So next, we are sending it for the exploratory data analysis. So here, this step, the data processing and cleaning the data includes data wrangling, data scrapping, data cleaning. So this will make the data into the proper format. I can show an example here. For example, the raw data, it can be an Olympic records or any emails or any genetic hospital data, the data from medical field or the institution data. All these are the raw data. So this data has to be processed and it is analyzed to move to the next step. And as I said, this data cleaning, so it involves data munging, and it includes data joining, data scrapping, and data wrangling. So this is nothing but a pipeline process. So it is sent one by one. And for data cleaning, we can use a Python, shell scripts, R, or SQL, or all the above. So here, we are converting a raw data into the proper format. The format, for example, it is if the raw data we have sent, you can see the format here like name, event, year, gender, event. So thus the data is formed into the proper format. So we get the data into the nice format, something like this. So next, here, after doing EDA, so we are able to identify any duplicate data, any missing data at the lower outlier, okay, and what is the lower value, the range, upper value, and any the missed data. So using this, we'll go back to the figure. So once we get the EDA, then we can send the data to the next step, that is to build the model. If EDA output, if EDA is not done properly, what we'll do is we'll go back to the first step, again go collect the raw data, process the data, clean the data, and come back. This is what we are doing in the data science team. So once the EDA is done, that means once the data is in the proper format, then we're using machine learning algorithms will build a statistical model. So later I'll be talking about the statistical model. Here we'll building a using machine learning algorithms, we'll build a model, we'll build the applications. So this applications, again, it is visualized using many visualization tools. It was communicated to the industry CO team, and we are then they will generate the reports. So once it is done, okay, then the data, the product is delivered. That is, I gave many examples in my previous slide, like recommendation system, Facebook recommendation system, Amazon, like all these are the data products. Again, it is used by the people. So here you can see the arrow, again it is connected to the real world. So it's a loop. I can say this data science process is a loop. So here again, identify the problem, collect the data, do EDA, build the model, and generate the product. So this is a loop. So again, after building a model, here, as I said, once the model using machine learning algorithms, a model is generated, and using the report is sent to the higher authorities, and using this visualization or the report, they will make a decisions. So what are the different steps in making a decision? So they interact, visualize, and report or communicate the results. So this could take form of reporting the result, and they can publish the results. So the main step of the data science is setting up the environment, loading the libraries, loading the data sets, and doing a basic data exploration, visualizing the data, and doing a data analysis, and building a machine learning model. So these are the different steps in the data science process. So now, what is the role of data scientist? Again, as I explained the data science process, now I'll be telling what is the role of data scientist here. So the first three steps, as showed in the diagram, this first three steps, so the raw data, data is processed, cleaning. So this is done by the data scientist. So here you can see in the diagram, so raw data is collected, the data is processed, data is cleaned. So how the raw data is collected. So it can be a data from the email, logs, medical records, or the data from the different surveys, the blood reports, the Olympic records, all those are the raw data. So next, the data is processed. The data is processed, they use cleaning, mugging, joining, scrapping, and many more methods. And the data is clean. So they use outliers, missing values, debugging. So using this, they will get the output that is nothing but EDA. So this task is done by the data scientist. So now, how can I connect this to the scientific method? So data science process is an extension or variation of a scientific method. So they can ask a question, do a background research, they can construct the hypothesis, test the hypothesis, analyze the data and draw the conclusion, and finally they can communicate the results. So take the raw data, analyze the data, process the data, build the model, do the experiments, generate the report, analyze, ask the questions, formulate the questions, and finally communicate the results. So this is nothing but a data science. So I can show the difference between the machine learning and the data science process here. The machine learning, so it is nothing but developing a new model. It is nothing but developing an individual model. Whereas a data science, it is exploring many models, building the model, and it is a hybrid. In machine learning, so it proves the mathematical properties of the model. Whereas the data science, they understand the empirical properties of the model. The machine learning, they improve or they will take the data from the small data sets. Whereas in the data science, they mainly handle the massive data. They develop the tool that can handle a large amount of data, unstructured data. So those machine learning, once a model is built, they'll publish it. Whereas the data science, they formulate the question, and if there is any future problem, so they will take an action. So that is nothing but the difference between machine learning and the data science. So recently one case study is they're done using a data science that is about the cancer research. So there are many machine learning algorithms they are built to predict the cancer. As we all know, it's a complex disease. So there are many more machine learning advanced algorithms are built. But recently they formed a data science team, that is a Stanford Medicine Google team, to harness the power of data science for healthcare. So they formed the team and scaled the Google Cloud platform to support precision health and more efficient patient care. So they analyze, data science team, they will analyze the genetic data and they focus on precision health and data as an engine. They mainly dealing with the research. So now I'll be talking about the data visualization. So as I said, what happened in the data science, finally the output, they're viewed using the data visualization tools. The output is seen using the data visualization tool. So once you know about the data science, you should know about the data visualization. So how the output is viewed. So data visualization is a graphical representation of information and data. It enables the user to see the patterns, trends, and outliers in the large data sets. It mainly the data visualization, it helps in better decision making and it will tell the business, it's a data storytelling. So in the data visualization, the importance of the data visualization is to simplify the complex data, and mainly it will enhance the decision making. It will identify the different patterns in the data. They will engage the audience effectively and they helps in predictive analysis. So these are the importance of data visualization. So we need to, when we see the output using the data visualization tool, so it is more understandable. So they mainly enhance the decision making, they identify the trends and patterns, and also they engage the audience. So what are the different types of data visualization? So the different types of data visualizations are charts, tables, graphs, maps, infographics, dashboards, network diagrams, tree maps, all those are the different types of data visualizations. Again, in the chart, it is later I'll be showing the execution of the different data visualizations using the Later, I'll be explaining those tools. So now this chart, they mainly used for comparing the data, showing trends and distribution like bar chart, line chart, pie chart, and scatter plot. So bar chart, it is mainly to compare the different categories. Line chart, it shows the trend over the time. And pie chart, it is mainly to show the propositions of the data. And scatter plots, it mainly shows the relationship between the variables, outer lower variables and lower outlier and upper bound outlier. So it will show the relationship between these different variables. So these tables, they mainly used for displaying structured data in rows and column for easy comparison. And in the graph, there are again different varieties of graph like histogram, box plot. Again, the box plot, there are different types, that is a box and whisker plots. And in the maps, geospatial maps, heat maps, choropleth, all these are the different visualization tools. One more visualization tool is infographics. It is made the combination of visuals, icons, minimal text to present the informations. There is a tool called dashboards. It is used for the business intelligence and performance monitoring. And the network diagram, that mainly to deal with the relationship and connection between the entries. So it is used in social network, web analytics, and telecommunications. So later I'll be showing all this graph using a tool. So the tools, the popular data visualization tools are Tableau, Power BI, Matplotlib is in Python, or D3.js and Google Data Studio. So I'll be executing some Python code and I'll be showing the different graphs. So best practice in the data visualization is choose the right chart type. So based on the problem, identify the chart. So if it is a comparison, go for the bar chart. So based on the problem, identify the chart. Keep it simple and readable. Use the appropriate colors. So label the axes and different legends and maintain the data accuracy. So when we use a data visualization tool, so we must consider these different practices. So data visualization is mainly, it is essential for data-driven decision making. It will effectively visualize, improves communication and insight, and it uses the best practices and the right tool. So I'll be executing all different programs to show the data visualizations. Whether my screen is visible? My screen is visible. So here you can see the Python codes. So we need to import the different headers, Python header, that is Python libraries, NumPy, pandas, and the important function to plot as matplotlib library, and use a seaborn, import seaborns to view the graph. So I'll be executing to show the functionality here. The first is about the tick. So here we can see the different markers. This O indicates a circle marker and S indicates a square marker. So here I have given the point marker that values 2, 4, 6 and 8, and I mentioned a circle marker that is indicated by O, and one more values what I mentioned here is 1, 5, 9, 30, and I have given a square marker. So this snippet will explain about the tech. So next I'll be showing one more examples. So again, given the values and with the different labels, I've given 4 different labels, and here the rotation I've set it to 20. So I'll modify this. So this is nothing but the rotation. So you can see the label here it is rotating. So next I'll be showing the two function, that is a text and legend function. So here I've given the text, like the text in the data codes, and I mentioned that I've given some values and have set some colors here. So you can see here. So these are the different legends. So x-axis, you can see this text in the data records. And here I set the color yellow, and the font size are given here, and the label are given here. So thus are different styles which we are using in the Matplotlib. And the important chart, already explained the different charts like bar chart, pie chart. So here we can see the bar chart. Bar chart mainly we are using for the comparison. So here you can see there are 4 different labels, that is A, B, C, D, the different values. So I can change the values. So plot.show, it will display the output. So here I've given the values 80, 70, 60 and 50, and you can see the changes. So one more chart. So the comparison here we are doing is in the bar chart, and you can see here the different values. So this is one more data visualizations. And so this is a pie chart. So 3 different categories, 4 different categories are shown here. That is A, B, C, D. And we have mentioned values 0 0.4, 0 0.3, 0 0.2 and 0 0.1, and with the labels A, B, C, D. So plt.show, it will execute this. So this is the pie chart. So these are the different visualization outputs. Stacked bar chart. So this is stacked area chart. I can show one more data visualization, that is histogram. Histogram. It's box plot. And you can see the scatter plots. Subplots. So these are the different data visualizations. You can see here. So I'll go back to this. So as I said, in the data science process, the output is mainly seen using the data visualization reports. So that is communication, visualization, and report findings. It's the main step to take the decisions. Based on this, the business, they will make a decisions. So next, I'll be talking about building a model. So what is modeling? So once the EDA is done, so the data is processed, data is cleaned, data wrangling is done, data scrapping is done. So once it is done, now EDA output is ready, then we are sending the data to build the models. So what is model? So it is a representation. So a statistical model is a mathematical model with the set of statistical assumption concerning the generation of sample data. So it represents a massive amount of data. So it has a large amount of data, and using this data, they will build the model. So here we should know the concept of population and sampling. So population is nothing but all the data. For example, all the male, I can call it as a population. In that large amount of male, I'll be taking some set of male. The subset of population, we call it as in sampling. So the main step of modeling is sampling. So build the model, sample the data, then build a model from the sampled data. So here, statistician and data scientist, they capture the uncertainty and randomness of data with the mathematical functions. They apply different assumptions, mathematical functions, then they express the shape and structure the data. So now in simple, I can say what is model. So we know the architects capture the building model. So before they build real house, so they will build a basic model. So here also the architect capture attributes of building through blueprints, 3 dimensions, scaled down versions. So now molecular biologist, so they capture the protein structures with a 3-dimensional visualization of the connection. The statistician and the data scientist, they capture the uncertainty and the randomness of data with a mathematical function that exactly it will shape the data and give the meaning for data. They will structure, they will convert the unstructured data into structured data. So a model is an attempt to understand and to represent the nature of reality through a particular lens. It can be an architectural model, or it can be a biological model, or it can be a mathematical model. So I can say a model is an artificial construction where a large data, extraneous detail has been removed, or unwanted data is removed. So in case of protein, a model protein backbone with side chains by itself is removed from the law of quantum mechanics that govern the behavior of electron, which ultimately dictate the structure and action of protein. So the statistical model should not exclude any key variables, and they build a statistical model. They should make sure that they included all the relevant data and they excluded irrelevant data. So the mathematical expressions will generate enough into parameters, but the values of these parameters are not yet known. It is not yet given. So in the mathematical expression, they use many Greek letters for the parameters and Latin letters for the data. For example, if I have the two variable x and y, the relationship between the linear relationship, I can show it as y is equal to beta naught plus b1 into x. So here we don't know what is the exact value of beta naught and beta 1. So here you can see here the statistical model. So statistical model is a use of mathematical model and statistical assumption to generate the sample data, and they make the prediction about the real world. So statistical model, so using some assumptions, they will build the model and they will do the predictions. So this is done only by the statistician. Since the data science team is, it contains a statistician and the computer engineer, so they make this model into the proper real time. So the statistician model is a use of mathematical model and statistical assumption to generate the data, and they make the prediction about the real world. So when the real engineers, when they join with the statisticians, they can build a real world products. So statistical model is a collection of probability distribution and on a set of all possible outcomes of an experiment. So it is a process of describing the connection between the variables in a data set using mathematical equation and statistical approaches. Now the question is how to build the model. So how do you have any clue what function form the data should take? So first, to build a model, the first important step is, as I already explained, as performing EDA. So to build any model, the first and the foremost step is exploratory data analysis. Do EDA. So this EDA, it identifies the missing data, and it will check with the data is ready for the next step, ready for the execution, ready to build the model, and it will identify that the data is relevant. So it is a trial and error, and it is an iteration process. If the data output is not satisfied, go back, collect the raw data, do the cleaning, process the data, again get the output. So this is EDA is a cyclic process. The first and foremost step in modeling is doing EDA. Next, now check the EDA output using our data visualization tools like I said, the histograms, scatter plots, to start getting feel for the data. So when you view the data using these tools, when you view the data using a bar chart, pie chart, or a histogram or a scatter plots, so you can feel the data, you understand the data, get the intuition about the data. So you'll understand the data in a better way. So then try something down, even if it is wrong in the beginning. So once EDA is done, once you view the output, now write down the linear functions. Next, when you write the linear function, so it'll be not knowing many values. The many values are undeclared. For example, I give the linear equation example in the previous slide, that is y is equal to beta naught plus x beta 1. So there the variables are not declared. So what you do is building it up in a complexity, make an assumption and write your own assumption, and taking different outputs, trial and error manner, taking words and trying to express them as an equation and code. So simple model may be easier to interrupt and understand. So you can see here different types of statistical model like linear regression model, logistic regression model, time series models, multi-level models, equation models, clustering models. So these are the different models. These are the different statistical models. These are the different statistical models. So here you can see the statistical modeling techniques. So one is regression analysis, factor analysis. To build a model, so what are the different techniques are required. One is a regressions, factor analysis, the neural network, the decision trees, survival analysis, time series analysis, and the cluster analysis. So these are the different modeling techniques. These are the different routes, different methods to build a statistical modeling techniques. So now I'll be talking how to build a statistical method. The first step in building a statistical model is knowing how to choose a statistical model. So choosing the best statistical model is dependent upon several different variables. So first, to build a statistical model, first we start with the graph, visualize the data, identify the errors, understand the variables, working with how they look, how they behave, and why. So understand the intuition of the data. So understand the relationship between the different variables of the data. So just check which data is missing and fill the data. So this is the first step in building statistical model. Next, to build a predictor, in theoretical distinctions, relate the variables with the different scenarios, then outcomes once the sets are combined. So now build the predictors. So there are different, to make a complex system, so first you club the different components, then see the different predictions. Next, run the descriptor with the graph in order to visualize the data and understand how each potential predictor relates individually to every other predictor and outcome. So frequently record, compare, and interpret the result from model with and without control variables. Next, eliminate the non-significant interactions first. So that means eliminate the unrelevant data. Any variable involved in the significant interaction must be included in the model by itself. And finally, identify the many existing relationship between the variables, categorize, test every possible predictor, and be sure not to lose sight of the research questions. So once the statistical models are built, once it is done, next we need to know about the probability distribution. So what is probability distribution? So the probability distribution is a foundation of statistical model. So it's a measurement generated by the real world process, which will turn the data into the proper shapes. So the measurement generated by the real world follows some mathematical shape. The classical example is the height of human. So it follows a probability distribution that is a normal distribution. The height of a human can be represented using a bell-shaped curve called a Gaussian distribution and called as a Gauss. The parameter for the mathematical functions can be estimated from the data. The natural process tends to generate the measurements whose empirical shape could be approximated by mathematical function with the few parameters that could be estimated from the data. So not all processes generate the data looks like name distribution, but many do. So in probability distribution, when modeling the data, the probability distributions are used to show how the data is distributed over various values. Data scientists can discover the underlying pattern in the data by fitting the probability distribution of the data. So the definition of the probability is to which something is likely to occur. So we can say using the probability distribution, we can see this, we can predict the next scenario. So a probability distribution is a statistical function which describes all different possible values for a random variable with a given range. So this range will be bound by minimum and maximum possible values but where the possible values would be plotted on the probability distribution with the determined by the number of factors. So here I can show some examples for probability distributions. So one probability distribution here I'm showing is the normal distribution. Here you can see the parameters, that is mean and median, and control where the distribution is centered. So this is a general function for the real world phenomenon, that is normal distribution 1 by sigma square root of 2 pi. So these are the different probability distributions, like normal distributions, uniform distributions, Gaussian distribution, F distribution, chi-square, gamma, so log normal, normal. So these are the different distributions. So now I'll be talking about the probability distributions. So it's a random variable which is denoted by X or Y, which can be assumed to have a corresponding probability distribution, that is P of X. If X or Y is a variable, then its probability distribution I can represent as P of X or P of Y. The value of P of X or P of Y will be a positive real number. So I can give an example. Let X be the amount of time until the next bus arrives. So this I can show it's an exponential distribution where X is a random variable. There's a variation and uncertainty in the amount of time until the next bus. So you can see here, the time until the next bus has a probability density of P of X. We can predict what is the likelihood of the next bus arriving in between 12 and 13 minutes. I can show in this way. So it is nothing but, so that this is a exponential distribution showing the arrival of the next bus. So I give the example for the exponential distribution. So it's a continuous probability distribution that often concerns amount of time until some specific event happens. So it's a process which event happens continuously and independently, that we can call it as an exponential distributions. So the data science process, once the raw data is read, once the data is processed, once the data is cleaned, next the EDA output will be success. Once we get the proper EDA output, we are sending the data to build the model, and to build the model we need these distributions. So the exponential distributions, as I said, it is mainly for the continuous data. Next, what is joint distribution? The joint distribution, there is a probability that encompasses 2 or more random variables. It encompasses 2 or more random variables. Next is conditional distribution. The likelihood of the event A, conditional distribution as, it shows the relationship between the two events, like event A happening given at another event B is already occurred. So for this, we call this in conditional distributions. So you can see here in probability notation, this is denoted by A given by B, which is expressed probability of A given the probability of B is given. So this indicates that probability of event A is dependent on the occurrence of event B. So the condition, so based on the B conditions, we are identifying the condition probability of A. So this is known as conditional distribution. So you can see here different distributions like exponentials, joint distributions, conditional distributions. So I can explain this probability distribution with an example. If we consider X to be a random variable that represents the amount of money spent, then look at the distribution of money spent across a user, that is P of X. If X is a variable which represent the money spent, the probability of that X I can represent using P of X. So it takes the subset of the user who looked at more than 5 items before buying anything. So my aim is to represent the amount of money spent. So how can I identify us? So it takes a subset of the user who looked at more than 5 items. That means the money spent is more. So it is more than 5 items before buying anything. And they look at the distribution of money spent among this user. So if y condition is given, if y be the random variable that represent the number of items, then for example, if I represent y is 5, so the probability of x when y is greater than 5, we call this as a conditional probability. So as I said, the conditional probability means P of A by B with the probability of finding the probability of A when the condition of B is given. So the realization of pair of random values x1, y1, x2, y2, etc. So entire data set with n rows and k columns, we are observing the n realization of the joint distribution of those k random values. So next is task. So in the data science, once EDA is done, next they will build a model. So to build a model, as I explained, the statistical distribution, statistical modeling with the different distributions. Once the different distributions are used, the statistical model is built. So once the model is built, we need to fit that model. We call it as fitting a model. So fitting a model means estimating the parameters of the model using the observed data. So in my previous slide, I gave the example, x is equal to beta naught plus y into beta 1. So here y is an observed data. So how to predict the value for that y? So that is nothing but fitting a model. So fitting a model means estimate the parameter of the model using the observed data. So using the data as an evidence to help approximate real world mathematical process that generates the data. So model fitting is a measure of how well a model generalizes to similar data to that one it was trained. So fitting the model often involves the main aim of fitting a model is to generate the optimized model. So the fitting the model often involves optimizations using different methods and algorithms like maximum likelihood distribution, maximum likelihood estimations to get the help parameters. So when you estimate the parameters, they are actually the estimators, meaning they themselves a function of the data. For example, had given one linear expression, y is equal to beta naught plus x. So here the values are predicted. So this is nothing but, so based on this values, they will fit the models. So main aim of fitting the model is to generate the optimized model. So sometimes during fitting a model, there is a case called overfitting. So overfitting is a term used to mean that use the data set to estimate the parameter of the model, but that model is not good at capturing the reality beyond the sample data. So when the proper values are not predicted, then we call it as an overfitting. So it occurs when the model gives accurate prediction for training, but not for the new data. So this is about that statistical model. So in this data science, so may I explain about the raw data collections, how the data is processed and how the data is cleaned and how they are doing an EDA. So this EDA is a very important steps. Then using a machine learning algorithms, they will build a statistical models. So to build the statistical models, they use different probability distributions. So once build a model, they will fit the model. Again, they should make sure that the data, it is not overfitted, the proper assumption has to be taken, the proper distribution has to be taken. Again, the distribution is chosen based on the situation of the problem, based on the situations. So again, if this is not proper, then go back to the EDA, again build the model and generate the reports, visualize using different visualization tools, and communicate the result with the higher authorities. So once it is fitted properly, then finally you can go for the product. So the best example, as I said, the Amazon recommendation system is a data science product, which is used by the real world people. So this is about the data science process. So next I'll be talking about So I'll be showing some more examples using a data visualizations. So in the data visualization has shown the different graphs. So I can show EDA process, how the EDA is done, EDA reports I can show here. I'll upload some example here. So it takes some time for the execution. So it is taking time for execution. Here the data set has to be loaded. So this is what I can say, that the data analysis, the data scientists, and the big data professionals plays a very important role in taking a decision in the business process. So all three together makes, I can show. So this, I have already explained this network examples. So these three T make a very important, they perform a very important role in building a model. So mainly they helps to make a decision in the business process. So the big data professionals, data analyst, and the data scientist. So the data analyst is a subset of data scientist. So I can show the data science profile. Sorry. So the data science profile. So in the data science, the statistician plays a very important role. So you can see here. So the statistician plays a very important role. Then the mathematician and the computer scientist, then the machine learning and the communications, then the data visualization domain experts. So these three all together makes a data science team. So as I said, the data science, it contains theories from the different fields. All these people together, they will make a data science team. So you can see the data science team, and who is a data scientist in academia. So the data scientist in academia is the one who does the research. So it can be a statistician, a mathematician, the computer scientist, or the journalist, a socialist, or a scientist. So they all call it as a data scientist in the academia. So or a biomedical informant students, a student from the government agencies, a social welfare, and someone from the architect school, environmental engineering. So all this we call it as a data scientist in the academics. Whereas in academics, a data scientist is a scientist who are trained from social science to biology, who works with the large amount of data and who solves the computational problem with the complexity. We call it as a data scientist. So the data scientists are available in academics who solves the real world problem. We call it as a data scientist. And in the data scientist in the industry, so there will be a chief data scientist setting everything from the engineering infrastructure till the generating the reports. We call it as a data scientist. So setting everything up from the engineering and infrastructure, collecting data, logging, deciding what data will be user facing, how the data is going to be used to make a decision, and how it's going to build back to the products. So a chief data scientist role is starting from setting up the infrastructure till generating a product. That is a main role of chief data scientist. So he is able to manage a team of engineers, scientists, analysts, and he should communicate with the leadership across the company, including CEO, CTO, and product leadership. In industry, someone who knows how to extract the meaning from and interpret the data, which requires many tools and methods from statistics and machine learning with the human. So here spends a lot of time in processing data, that is cleaning the data, collecting the data, munging the data, because the data is not clean. So the data has to be processed using different processing techniques. So this process requires persistent statistics, software engineering skills that also necessary for understanding the biases and for debugging, logging, and outcoming for the data. So next, already I said about the big data. So the problems which is faced by the big data is handled by the data scientist team. Since in the big data, as I said, it contains unstructured data, and now the data processing system, the traditional data processing system are not able to handle this unstructured data. So this is overcome. This problem is resolved by the data science team. So in big data, there is a statistical thinking. So it is an overall process of going from world to the data, and then from data back to the world. We call this as a statistical inference. So the statistical inference plays a very important role in the data science process. Why? Because as already explained, the data science, data science flow diagram. So there we started with the real world. So collecting the data from the real world and building a product, and we have after building a product, we are giving back the data to the real world. So this is cyclic process, and this we call it as a statistical inference. So it's an overall process of going from the world to data, and then from back to the world is a field of statistical inference. So it's a discipline that concerns itself with the development of the procedure, theorems, which will take the meaning and information that has been generated by the stochastic process. So here, next, I'll be talking about the population and the sampling. I'm just briefing out because I'm running out of time. So here I'm just talking about the population and the sampling. So as I said, the population is nothing but entire data. For example, entire Gmail, we call it as a population, and sampling is nothing but the subset of the populations. So this population and sampling plays a very important role in building a statistical model. So these are the different data we are facing in the real world. It contains traditional data, text data, records, network data, images, sensor data, etc. And the data will be in the different formats, JPEG, JSON, all those are different formats. All this data, raw data has to be processed, data has to be cleaned, then only we can generate the EDAs. So then already explained about the modeling. So thus overall I can say that the data science future, it is going to build a lot of products which will be really used in the business, and it's a developing projects are now, many projects are developed using a data science team. So many research work is going on the data science. So any questions?
Dear participants, do you have any queries? As we conclude today's valuable session, I would like to express my sincere gratitude to all those who contributed to making this session a great success. First and foremost, our heartfelt thanks to our esteemed resource person, Ms. Smita Shetty, for delivering such an informative session. Your deep insights into the topic, data science and visualization, have truly enlightened us. We appreciate the time and the effort you took to share your knowledge with us, ma'am. Next, I would like to extend my gratitude to all the participants of your active engagement. Once again, thank you all for making this session a success. We look forward to seeing you in the upcoming sessions and hope to continue this journey of learning and growth together. Now, I would like to hand over the next session to Mrs. Srija, Head of the Department, Computer Science and Engineering, Macet. Over to you, ma'am.
Good evening to everyone. It's my absolute pleasure to extend a warm welcome to our esteemed resource person for this session, Professor Anjana. Ms. Anjana is a professor in the Department of Computer Science and Engineering at Manipal Institute of Technology, Manipal. Her research focuses on multi-cloud security, artificial intelligence, machine learning, trust in computing, computer security, and cybersecurity. With extensive experience in academia and research, she explores cutting-edge solutions for securing cloud environments, enhancing trust in AI-driven systems, and mitigating cybersecurity threats. Her work in machine learning and AI contributes to the development of intelligent security frameworks for cloud computing and digital infrastructure. Ms. Anjana has published research in reputed international conferences and journals, advancing knowledge in security, AI, and data-driven technologies. She is also actively involved in academic program development and student mentorship. We are honored to have her with us today, and we eagerly look forward to gaining valuable insights from her. Let's give her a warm round of applause. I will now hand over the session to Ms. Anjana. Ma'am, please take over the session.
Anjana madam is joining now.
Okay, Sunita ma'am.
So good evening, everyone. So now ma'am has joined now. So ma'am, we are honored to have her with us today, and we are eagerly look forward to gaining valuable insights from you. And now I will hand over the session to you, ma'am. Ma'am, please take over the session now.
Hello.
Yes, ma'am. Audible, ma'am.
Yeah. Sorry that I joined a little late.
Okay, ma'am. No problem, ma'am. Take over
Yeah,
the
I'll
session,
share
ma'am.
my screen. Yeah. Is my screen visible?
Yes, ma'am. Is it
Our
visible?
PPT is visible, right?
Yes, ma'am. Yes, ma'am.
Yeah. Good afternoon, everyone. Myself, Anjana here from Manipal Institute of Technology, and I'm very delighted to be the part of this Atal Fdp from your reputed institution. So here today, I'm going to present uh, on a topic of like building trust in cloud, which is like of very importance in the current scenario of where it holds many applications, especially like the case of healthcare, where the like an electronic medical record, which we called it as EMR, used to be shared and stored in many cloud, and many people have got an access of it. So as we know, there are many aspects regarding the security which need to be taken into consideration to make it more simple and to make it more secure. Trust is one of the major factor which has been talking nowadays. So let us have a little overview about this topic over here. So this is the table of content which I'm going to go through here. So we will explore different cloud computing models, key security concerns, and the role of trusted computing technologies, etc. Additionally, we will analyze some case studies that highlight the real world application of this security framework in cloud environment. Let us move on. So to start with, it will be always good to have a light recap of what we know about cloud computing. So cloud computing is, we can call it as a game-changing technology, which will allow business and individuals to access computing resource over the internet without the need for any expensive hardware or infrastructure. So instead of maintaining their own data centers, organization can use cloud services to store, process, and manage data very efficiently. Like if you look, one of the biggest advantage of cloud computing is its scalability. Business can expand or reduce their cloud usage depending on their needs. This means organization only pay for the resources they use, making it a very cost-effective solution. And cloud computing also enhance accessibility. Any employee can work from anywhere using cloud-based applications and data storage, improve collaborations and productivity. So as we can see, this field, that is cloud computing, continues to grow. It becomes essential to address security, privacy, and trust concerns, especially for critical industries like healthcare and finance. So by knowing about the cloud, it is very important to talk about its deploymental model, service model, etc. So first, let us look into the deployment model. So we have the different, as mentioned here, we have got mainly 4 different models we talk about. The private cloud, it is used exclusively by any organization to ensure higher security and control, because they are the only one who use it. Nobody from outside the organization don't have any access with it. Next is the public cloud. The services are available to multiple users. It offering cost efficiency, but have got less control as compared with the private cloud. I'm not going into much detail of it. We're just recollecting some of the important points regarding the cloud computing. So the next is like the hybrid cloud. It's a combination of private and public cloud, balancing security, flexibility, and scalability. The last one we can say is of like community cloud, shares infrastructure among organization with the common security and compliance requirement, like such as a hospital sharing the medical records stored in them. So moving on, we have got cloud computing service model. So cloud computing services are categorized mainly into 3 main models depending upon their need and control levels. First one is software as service. It provides ready-to-use applications over the internet, such as we have used Google Docs and Microsoft 365, etc. Next one is PaaS, which is platform as a service. It offers a development environment for software creation, such as AWS, Lambda, or Google App Engine, etc. Then infrastructure as a service. It delivers computing infrastructure, including virtual machines and storage, like Amazon EC2. So most of the healthcare and financial institutions often use a mix of SaaS and infrastructure as a service to ensure both usability as well as for the security. Now, if you look at the security, if you talk about the security, privacy, and trust challenge, the cloud computing, if you look at, it is of most top priority among the major concerns in cloud computing. So there are several concerns that must be addressed for safe adoption. If security threats, if we take into case, we have data breaches, unauthorized access, cyber attacks, like they remains the major risk. Privacy issues are there. The users lose direct control over their data, leading to confidentiality concerns. Then the most important that people try to work nowadays or look forward with is about the trust and compliance. So organization must ensure that the cloud providers comply with the regulations. Various regulations are there. They go for that, like HIPAA, GD, PR, etc. The HIPAA is mainly for as like the case which I said, the use case which I said, like for sharing medical records is very important. Now, I'll take on some of the case study which will prove to be like very much, which convinces actually like the need of the cloud computing. So first of all, let us take into this one, secure healthcare data sharing in multi-cloud. The healthcare industry, it requires secure data sharing between hospitals, patients, and providers. Providers in the sense, if you say there will be an insurance company which is be involved, which need the patients, some of the sensitive information, not all information need to be shared. Some of the sensitive information need to be shared to them. And regarding their whichever needed to make sure to provide an insurance from their end, then there will be a researcher who needs some of the case of the patient's case history to which it will be for them, it will maybe needed to carry out certain research in medical area. And there will be a laboratory which need to share the various tests which is being carried on the patient. So likewise, there are many entities seen in this scenario, which need this data to be shared. And as this many people are involved, they will be using their own private cloud or public cloud, and data will be residing in many clouds in that scenario. So it is very much important to propose a secure multi-cloud healthcare architecture. So mainly we can look on with the data encryption, first to protect sensitive data, the patient record for unauthorized access. Next, if you look at the multi-cloud storage to prevent a single provider from having a full control over the patient data. Third one, privacy preserving access control to ensure only authorized personnel can view the medical approach. So if you look at these different approach, securing and privacy preserving medical data sharing is very important. So trust is, as we talked in the previous slide, the security threats, privacy, all that to maintain. The trust is playing a major role over here to make sure that it is properly shared to the known people only by selecting the sensitive data. So talking about the cryptographic technology for multi-cloud security, we have advanced cryptographic techniques for the security and privacy to ensure security and privacy in cloud computing. So mainly they use attribute-based encryption methods. It restricts the data access to a specific user's attributes, ensures only authorized users can view sensitive information. And another one is secret sharing. It breaks the encrypted data into multiple parts and store them across different cloud providers. So this will prevent unauthorized access. Like even if one cloud provider is compromised. So these cryptographic methods will provide an enhanced security in multi-cloud environment. So role-based access control, especially in e-health, if we take in healthcare, access control must be dynamic and it should be tailored to the user behavior. So there are traditional RBAC. It will assign users fixed roles, but this is not enough for the modern cloud environment. So keeping these in mind, like how we can better provide it by having a better framework in place for assuring the trust is important. And if you look at this optimized RBAC with trust mechanism, it dynamically monitors users' behavior. And it will adjust access based on real-time security risk. So these approaches will prevent unauthorized access and protect sensitive patient data. So trust-based access control in e-health. So trust-based access control adds an extra layer of security and risk assessment. It tracks users' action very dynamically and assign a trust score. So it restrict or grant access based on users' behavior. It reduces any kind of inside threats. So it ensures compliance with regulatory requirement like which I have mentioned in the previous slide, like HIPAA, and thus enforce strict access control. So here, mainly it takes care of security and efficiency in healthcare systems. So looking at the trusted computing technologies, there are several technologies that help establish trust in cloud computing. First one is like a trusted platform module. So it can provide a hardware-based encryption and secure boot process. Second one is virtual TPM. It can extend TPM security to virtual environments. Then like TSS, trusted software stack. So where like exactly a framework as we are talking about can be in place where based on a particular requirement on how the data wanted to be shared and what data want to be shared, the framework can be in place. So whatever like virtual TPM or trusted software stack we have, we can actually keeping them as in a base and we can like dynamically modify it according to the requirement. So here it mainly ensures the integrity and authentication. Next one we can talk about is a trusted network connect. So it verifies a trusted devices before allowing the network access. So in person, like how it is something of like two computers are come in touch when they are being shared. Like first we have certain uh, doubts in our minds before, as like normally in our day-to-day life, how we trust a person who is coming in front of us. So in the same way, we can create the model and we can frame this entire framework in which the communication happens. So all these technologies play a very crucial role in establishing trust in the cloud environment. Now, talking about multi-cloud security and benefits. So I have already mentioned what is the role of multi-cloud in the scenario, in this scenario of like if we take the case of sharing an electronic medical record in an e-health scenario. So there are several advantages. It reduces dependency on single cloud provider, minimize every security risk. Second one, it prevents the cloud service provider from accessing sensitive medical record, ensuring patients' privacy. Next, enhancing security through distributed storage, reducing the impact of potential breaches. So all these approaches are critical for handling many other industries which deals with sensitive data. Another one example which we can think of is like in finance. So in order to conclude, if we say to summarize, so the cloud computing offers a very scalable and efficient method, but it requires some strong security measures. And if we talk about the multi-cloud and trust-based access control, it enhances security and privacy. And a trusted cloud computing framework, it has been convinced all this what is existing has been convincing need to be in place to ensure regulatory compliance, privacy, and trust, etc. So I'm just concluding my talk here. And if there is any discussion needed, it is the form is open and we can have a discussion here. Hello. Hello.
Hello, ma'am.
Yeah. Yes, ma'am.
You can proceed, ma'am. No problem.
No, I have concluded.
Oh, finished.
Yeah.
Okay. 1 second, ma'am.
Any questions, ma'am, from any participants? Anyone want to have any clarifications here?
Dear participants, do you have any queries? No, ma'am.
Hello, am I audible?
Yes, ma'am. 1 minute, ma'am.
Yeah, I will do one thing. As the time is there, I'll share one of the framework which has been which is there to explain about this e-health scenario.
Thank you, ma'am.
I'll share another
As we
slide.
come to the end of this enlightening session, it's my privilege to extend a heartfelt vote of thanks. On behalf of Marthandam College of Engineering and Technology, I would like to convey my sincere gratitude to our esteemed resource person, Ms. Anjana, Professor, Manipal Institute of Technology, for taking the time to shape his valuable insights on how to build trust in the cloud. Thank you, ma'am, for sharing your time and expertise with us today. Thanks a lot, ma'am. As we come to the close of this 6-day online faculty development program, it's my privilege to extend heartfelt gratitude to everyone who made this event a success. First and foremost, I express my sincere thanks to the Marthandam College of Engineering and Technology Management for their unwavering support in organizing this program. A special thanks to our chairman, Engineer F. Prince Vinu, for his leadership and encouragement. I also extend my gratitude to our principal, Dr. C. Sudhakar, for his continuous guidance and motivation. A big thank you to our dedicated program coordinators, Dr. Jaisi Prabha and Dr. Martin, whose efforts ensured the smooth execution of this FDP. I also appreciate the hard work for all the Atal academic coordinators for their valuable contributions. We are deeply grateful to all our resource persons who shared their knowledge and insights, making these 6 days enriching and informative. Lastly, I extend my heartfelt appreciation to all the participants for their active involvement, enthusiasm, and commitment to learning. Thank you all once again for making this FDP a memorable and meaningful experience. Thank you all once again. Thank you.
Thank you, Shrija ma'am. Sanita ma'am, have you connected? Sanita ma'am?
Yes, madam. Yes, madam. Yeah. I will continue with the first session, madam. Okay.
Okay,
Yeah, I
ma'am.
will continue. Yeah. 1 second, madam. I'm sharing my screen.
Okay, Sanita.
Can you able to see the screen?
So, no, Sanita ma'am.
1 minute. I think now you can see, no?
It is started to sharing.
Okay, fine. I think now it's visible.
No, yes, Sanita.
Okay, fine.
Okay. Thank you, Sanita.
Thank you, ma'am.
We
I
are
have to
going to
say
enjoy your presentation.
Yes. Thank you so much for that day. I could not continue because I have prepared 2 models. I could explain only 1 model. So hope you remember I have given some introduction about the heart disease prediction. So we have studied about the heart disease prediction, missing data imputation, how we are substituting the missing data imputation. So now I'm going to explain you or discuss with you for the another one feature selection technique. That is squirrel search optimization. Okay, so I'll start with okay, just a minute. I'll just Oh. Okay. The squirrel search. First of all, I'll tell you what exactly the feature selection technique. Why feature selection technique is required for the why feature selection is required for the machine learning technique. We already discussed the purpose of feature selection technique in the 8th session. Basically, as I told you in my my hard disease data set, there are like 13 plus 1 attributes were there. So here, the feature selection is a process of reducing the number of input variables when developing a predictive model. Because of the large amount of data, see, because now we are seeing day by day the data are increasing, especially when we see our heart disease data set. Not only heart disease, any medical or any kind of this one data, if you take day by day, it is increasing. So the large amount of data, also the feature selection has become more important, because we need to n number of the features are there. So somehow we wanted to reduce that features, so that we will whatever the model we are creating, that will give us a better accuracy. So it is desirable to reduce the number of input variables to both the number of input variables to both reduce the computational cost of modeling, and in some cases to improve the performance of the model. So here also we'll see there are some step-by-step feature selection process are there. Different feature selections are there. That first we will initial the data exploration, then we will evaluate the criteria. So like that, we have so many process are there. So directly I will move on to my model, that is the squirrel search algorithm. So here basically the squirrel search is a nature-inspired meta-heuristic algorithm. It is proposed in the year 2019 by Mohit Jain. Also, it mimics the foraging and gliding behaviors of southern flying squirrels, employing these behaviors to explore and exploit the search space effectively. There are four key features for the squirrel search algorithm. The first one is population-based approach. So the population-based approach is nothing but the particular algorithm operates with population of squirrels. That means we are going to see how many squirrels, the total number of squirrels. So each representing a potential solution in a multi-dimensional search space. Basically, this will be in the foraging, that forest, this thing, how the squirrel is searching the food based on that we are going we are going to use this particular this one algorithm. So the second feature is like position and fitness. The position of each squirrel, because the first thing is we are finalizing how many population, how many squirrels we are that population we are going to use in our model. The next thing is we need to calculate the fitness of that squirrel. So that corresponds to different design variables and the different to food. That means that it represents the fitness value of objective function. So we'll calculate, suppose if it example that 10 squirrels, that means 10 is the population, means based on that we are going to calculate the fitness value. Then the next key feature is the movement. So individual squirrels alter their position based on their foraging strategies. That foraging is nothing but to improve their fitness by moving to better position in the search space. For example, this particular algorithm simulates a forest environment, because we are using the squirrel, the name squirrel, with 3 types of trees. Okay, so there are 3 types of trees. First tree is normal tree. So normal tree is nothing but there is no food, representing less optimal areas. Then the second one is acorn trees, as it is the secondary source of food. It representing the moderate fitness. Then the third one is hickory trees, the best for foraging area. It representing the optimal solution. So then the novel aspects of this squirrel search optimization is there are like there are four novelty. This algorithm incorporates several innovative processes that enhance its exploration and exploitation capacity. So based on that, the first one is the distributing the population. So the population in the sense number of squirrels. So here the squirrels are distributed across the forest. So ensuring, because searching the food, ensuring diverse exploration of the each space. The secondly, it is dynamic foraging behavior. The squirrels adjust their foraging strategy based on the environmental changes and the availability of food, allowing for adaptive explanation. Then the third novel aspects of the squirrel search is seasonal adapting intelligence. That is nothing but this particular algorithm adapts to seasonal changes, mimicking how squirrels prepare for different conditions. Whether it is because again the matter of how, whether the climate also constraint is there, also because some climate some kind of food will be given, so all those things are constraints which influences their search strategies, how it's search the food. Because as I told, there are three types of trees, and as well as there are that climate, based on the climate the food behavior also changes. So the next novel aspect is random repositioning. So at the end of the winter, that is summer, winter season, the squirrels randomly reposition. So basically, first the squirrel, for example, 10 squirrel we are considering population. So the first it will be 10. Then after that, when the this one season changes, the squirrels randomly reposition themselves to avoid local optima and explore new areas of the search space. So we will just find the search space based on the new space. Now, okay, there are maybe if you go through the squirrel characteristic, all those things will be there. So how we are going to use in the our model, that only I am going to explain. Also, the thing is why why the squirrel search algorithm is required. So the first important thing is when we use squirrel search optimization, exploration and exploitation balance is there. Then the second one important thing is it is a flexibility. Then the third one is the novelty in modeling. So the first one is exploration and exploitation balance. So that means this squirrel search optimization algorithm effectively balances the need to explore the new solution and exploit known good solutions, making it suitable for complex optimization problems. So that is the one of the use of the squirrel search algorithm. The second one is flexibility. So this algorithm can apply to various optimization tasks, including as we are going to see, the feature selection, also parameter tuning and resource allocation. Then the third use of this squirrel search optimization algorithm is novelty in modeling. That means by mimicking the dynamic behaviors of squirrels, this particular algorithm provides a fresh perspective on search algorithms, leading to potentially superior performance in certain contexts. So we'll see the example application by using, because our my application is heart disease prediction. So the how it will perform. The first thing is the initialization. Okay, so initial the data in exploration. Okay, so first initialization. First, what we have to do is first we have to define the population of squirrels. So population means total number of squirrels, each representing a subset of features from the data set. So the squirrel 1, some subset, squirrel 2, some subset. That means, for example, if it is 10, so 10 subsets we are going to collect that from the data set. The second one is we are going to evaluate. So evaluation in the sense for each squirrel, evaluate the classification model performance. For example, accuracy. We are going to classify the model based on the selected features. That I will detail, I will explain you. Then after that, what it will also, the next, it will, next thing is, it is movement. The squirrels adjust their feature subset based on their performance and the foraging behavior modeled in squirrel search optimization. So the next thing is iteration. We know that when the squirrel changes the climate, that means summer to winter, so then the iteration, next iteration will start, because it changes the position. So then same thing will be repeated. The process will be repeated. That means allowing squirrels to explore new feature combinations. So when the next iteration comes, that means when the squirrel changes one position to other position, then again the second iteration will start. So again the same, all those things will happen. So it will again squirrel to explore new feature combinations. This catch the best performing subsets and adapt to changes in the search space. Then the next one is the final selection. After the several iteration, it select the feature subset that yield highest model accuracy. So we'll see we have so many, because so many iterations are there. So also we'll find so many subsets. From that, we are going to find which one will give us the best accuracy. Based on that we will accept that. So the initial data explanation is nothing but examine the data set. We have the data set in the Kaggle. Currently, I have developed that particular model is 303 data set only. That is very small data set, but we have other data set also, 20,000, like that it is there. So this first we need to examine the data set to understand the distribution features and their relationship with the target variables. So that is the first thing we are doing. Then we are just evaluation criteria. We are going to decide on criteria to evaluate the feature importance. For this example, we use correlation coefficients for numeric features and chi-square test for the categorical features, so that we can use some even depends on the problem, we can use different tests. Then feature selection methods. Here we are using the filter method. There are three types of method, feature selection methods are there. One is filter method. So here the filter method will calculate correlation coefficients of numeric features. For example, in the data set, age is there, also blood pressure is there, also serum cholesterol, and so like that we have around 13 attributes are there. So some numeric features, I can say these three against the target variables. So now I'm going to use the test category features. For this, chest pain type. So then the findings is we are going to find the age, serum cholesterol, and maximum. These are all the attributes what I am telling. Maximum heart rate achieved have strong correlation with heart disease presence. So based on that, we are going to filter that particular attributes. So the next one is the wrapper method. So the wrapper method, it will use a logistic regression model with forward selection. That means it will start with no features and add one feature at a time. Also evaluating the model accuracy. So it will check if I am using this particular this particular feature, whether what value I am getting. So that way, so that means we are determining the addings. That means maybe the age or the chest pain type or resting blood pressure or exercise induced angina. These are all the our attributes. So we'll see that improves the model performance significantly. We'll see which one will give the better result. So based on that, what we are going to is we are going to select. So which one is very significantly it is affecting the result. So based on that, we are going to use that. So next method is embedded method. So here this particular method train the random forest classifier, which provides feature, that is the classifier to score the important. Also, we discussed already that what is random forest and why we are using random forest, all those things. Then yeah, so the final selection is nothing but based on the findings from all methods, we are going to decide to keep the following features. For example, we already applied our squirrel search algorithm. Then we just already verified which one is giving for more this one. So based on that, we will select the final features out of 13, whether 5 or 6 or 3. So though only we are going to consider with those features. So here the ischemic, squirrel search algorithm. It is a population-based approach consisting of many squirrels in which each squirrel moves through a multi-dimensional search space to forage the food. That is the logic. So the position of squirrels are considered as different design variable, and the distance of the food from the squirrel individual is analogous to the fitness value of the object function. Yeah, so this is the model for the ischemic heart disease squirrel search optimization overall system model. So here, what we are here, the input of this particular model is UC heart disease data set. So this UC heart disease data set is that heart disease data set is collected from the UCA repository. Also, this which contains various features related to the patient data. Start with age and age, cholesterol level, etc. End with the it's a supervised learning. So supervised learning means I know already I have 303 record, means all these records I know that whether each patient have heart disease or not. That means it's a numeric classification. The class value will tell me that whether the patient is having a heart disease or not. If it is 1 means there is a heart disease. If it is 0 means there is no heart disease. So like that, the data set I have, that only we are using. Then that data set, first thing is the fuzzy based missing data imputation. So because in the heart disease data set, there are missing values. So we don't want to ignore, or we don't want to apply any values, biased values. So already the model which I explained in the 8th session, fuzzy based missing data imputation. That means we are going to use the multiple imputation technique for each missing values. So, first collecting the data set, get the data set from the UCA heart disease data secondary, this one. Then from that data set, I'm applying the fuzzy based missing data imputation algorithm so that all the missing values are removed, and I'm getting the proper without any missing value, the clean data set. So now this particular data set, after applying the missing data imputation technique, that particular data set I'm giving to the feature selection technique. So in the feature selection technique, here you can see, 1 second. Yeah. Yeah, see this here, heart disease data set, then this multiple imputation technique, that imputed data set, I'm giving the input for the feature selection technique. So here I'm going to use the feature selection technique, ischemic heart disease squirrel search optimization algorithm. So the first thing is we have to random the initialization. That means initialize the population of squirrels. So let us take maybe the squirrel number of squirrel 10. So that first we need to initialize the population of squirrel, where each squirrel represents a random subset of features from the data set. So that is why we are doing the random initialization. After random initialization, next step is we need to calculate the fitness value. So here, since I have 10 squirrel, so I'm going to calculate 10 fitness value. I'm going to get 10 fitness value. So each squirrel evaluate the effectiveness of its future subset by training a machine learning model. That is, example, logistic regression or decision tree. We have used the decision tree and measuring its performance. That means accuracy, precision, or F1 square. So after getting the fitness value, so the next step we are going to sort that particular value, sort it in the ascending order. So sorting and declaration and the selection. So sort the squirrels based on their fitness value. So we are calculating fitness value here. So then we are sorting the value in ascending order based on the fitness value. Why we are like sorting is because we wanted to identify the best performance feature subset for the further exploration. So always that the best one we will get from the this one fitness value. So then next we are going to, so the one position is over. Now what I'm going to do is I'm going to change the position because I cannot I cannot find that this is the best one. No, now what I'm going to do, I'm going to change the position of each population. So that means this in squirrel, this one characteristic is when the winter season comes, the squirrel will change his place. So the same way here also we are applying the same thing. So now the second time again the squirrel's position we are changing. So now it is generate the new position. Then again we are doing the same process. We are going to calculate the same 10 the squirrel fitness value we are calculating. Then we are sorting and we are selecting the best one. So like that we are n number of times we are doing. After doing all those things, that iteration, once the iteration is over, then we are because there is a check if the stopping criteria. That means stopping criteria is nothing but example, a number of iterations or convergence has been met. Okay, so because already in the program we will set that this is my stopping criteria. So based on that we are just keep on repeating that. If not, we need to proceed to generate a new position and for the squirrel based on the best performance subset and their current position. So like that we will repeat. After that, the next step is aerodynamic gliding. So the aerodynamic gliding is nothing but we are implementing glide, because in the squirrel there is a feature that is gliding behavior. So the gliding behavior where squirrel adjusts their position in the search space to explore new feature combinations. So now it will change the position and new combinations. So enhancing the balance between, that means maybe the first time the subset may be age, blood pressure and sugar, all those things. So when it is changing the position and again maybe the subset may be different. So like that we are exploring the new feature combination, enhancing the balance between the exploration and exploitation. After that, we are just doing the random relocation. At the end of each iteration, we are performing the random repositioning for some squirrels to diversity the search space and avoid local optima. So the next last one is the stopping criteria. The stopping criteria, it continues the process until the stopping criteria is satisfied. So this could be when a predetermined number of iterations is reached or when there is no significant improvement overall iterations. So this is what the ischemic or this is squirrel search optimization will do. After the process of the squirrel search, after getting the features, so next what we are going to do is we are going to this result that it will go back to the feature selection. We will select the best feature. Then we are just finding the optimized features. Then that we need to check whether what we are getting the feature, whether it is giving the whether it is giving better accuracy or not. So for that, I'm going to use the classifier as a machine algorithm that I've used this one, a random forest algorithm for evaluation for the optimization. So based on that, we can just check. So here, when we see the advantage of this one is, we are multiple times we are changing the position and we are getting so many subsets. Out of so many subsets, we will evaluate which subset is giving coming more time. So which maybe the age may not be the this important, because sometimes age is also important, because we cannot predict that our this one heart disease age also there is a matter. Also, if you consider male female, so male age group may different, female age group is different, definitely that give a significant change. So that's what here, maybe number of, when we are getting number of sets, subsets, so out of that we will see which combination is coming for more time. So that only we will select, that is, this is the important features. So based on this important feature, I am going to train my model and I am going to get the better solution. So that is the beauty of this particular algorithm. So now, yeah, so when we see the example, if we take the example for this, suppose anyway, data preparation, I'm just using the UC heart disease data set with features like age, sex, cholesterol, blood pressure, etc. This handle any missing value with the fuzzy logic. Okay, that is over. Now feature selection. First, we are initializing the population of squirrel, each representing random selection features. For example, one squirrel might select age, because we have n number of population, right? So maybe the one squirrel might select age, cholesterol, and maximum heart rate. We can't expect this. The second squirrel also will search this same thing. So yeah, like that, we will just we are changing the position and we are just getting all the subsets. Then fitness value, we are training the logistic regression model using the features selected by the squirrel search and evaluate the model accuracy on a validation set. Then after getting the fitness value, we wanted to select which one to select. So for that, what we are doing is we are just sorting it in the ascending order. So rank the feature subset based on the model accuracy, identify the top performing subsets. Then generate the new position. If the stopping criteria is not met, that means already we are defining some stopping criteria. That means we are telling these many iteration, or maybe some condition we are providing. If the condition is not met, then we are just generate the new positions and feature subset for the squirrels based on the best performance. Then after that, the aerodynamic gliding, this will adjust the position of the squirrel to explore new future combinations, effectively searching for subsets that may yield better accuracy. Then random relocation. Periodically reposition some squirrels randomly to explore different regions of the feature space. Stopping criteria repeats the process until a set number of iterations completed or no significant improvement is observed. After that, what we are doing is we are just repositioning, performing the performance analysis. So this performance analysis is after completing the iteration, evaluate the final selected features performance. For example, if the final subset includes the age, cholesterol, and exercise-induced angina, it will assess the model's accuracy and other relevant metrics. So now we'll see the algorithm for this particular model. So the first, you can see the first step is each initialize the population. So that we are defining the input parameters. So here the flying squirrel, each squirrel represents a potential solution, which in the case of set of feature, weights and parameter values for heart disease prediction. Here the feature includes, the feature could include the age, cholesterol level, blood pressure, heart rate, blood sugar, etc. Also, the random values are assigned within a defined range. So then the output of this particular algorithm is, the goal is to find an optimal feature weight combination that minimizes the classification error. So now generate the random location for n number of flying squirrels. N is the population. So here LD and so here you can see that LD and LD, UD, all those things. These are all the lower and upper bounds for each feature weight. So the random function here, we are using the random function. So this random function will generate the number between 0 and 1. So that means that randomly that values will be generated 0 to 1, maybe 0.01, 0.02, like that random values will be generated. So next thing is we are computing the fitness function for heart disease squirrel flying squirrel's location. So here each squirrel position is used as an input to the heart prediction model. So here, for example, we can say KNN, K nearest neighbor, support vector machine, or a neural network, all those things. So here the fitness function is computed based on the classification accuracy or error rate. Also, the distance to K nearest neighbors in a data set containing heart disease patient records. So the next step is, so here this one is represented the future weights for the patient that is I is patient I. So that 1, 2 up to the n number of patient. So then the next one is the sort squirrels based on the fitness. So here the squirrels are sorted in ascending order based on their fitness value. So the best squirrel, how we will, because we are, suppose if it is my population is 10, that means n is equal to 10. Then I'm just calculating the fitness value. Then I have to sort it in the ascending order. Out of this ascending order, I have to select which one is the best. So here we are selecting the best squirrel is the lowest error, or considered closer to the optimal solution. That only we are selecting. We are sorting of flying squirrels in ascending order depending on their fitness value. Then next one is next we are just repeating. Actually, we are repeating the same thing again and again until the stopping condition criteria met. Then repeat until the convergence. So we'll do the repeat this step 3 to 6 are repeated until the fitness value convergence and the maximum number of iteration is completed. So example, suppose application of heart disease prediction, I'm initializing 20 squirrels. So that means random feature weight sets for a machine learning classifier. Now I'm going to evaluate the fitness using the accuracy of a heart disease prediction model. That is the logistic regression classifier. Next, what I'm going to do is sort the squirrels based on their classification performance. Then after sorting that, they adjust the position using gliding behavior, that is moving towards optimal future weights. Next, I'm repeating until the model reaches the best accuracy. This is what this algorithm. So this data set already we discussed that there are total we have 13 attributes and 1 class value. So this is what we used for this model also. After applying this, received that convergence of best fitness value for ischemic heart disease squirrel search optimization model. So here, actually, the convergence behavior of this particular squirrel search optimization algorithm. Here, the x-axis represents the number of iteration. Okay, so that is the stopping criteria. We can say the stopping, that means 100 iteration. That means 100 times the squirrel will move and all the process will be repeated, changes the position. So also the y-axis represent the fitness value. So these are all the fitness value. This fitness value only we will just then sort it in the ascending order. Then we will select the best fitness value. So which typically corresponds to the classification error or objective function value. So here the key observation, when we see that the iteration number 0 to 20, the first between 0 to 20, at the beginning, the fitness value is high. You can see it is a little bit high. Also, it is around approximately 0.275, indicating a suboptimal model state. As iteration progress, the fitness value decreases sharply, showing that the optimization process is rapidly improving the model. So this this phase is exploration stage, where a squirrel search broadly for the best solution. Then stabilization after the 20th iteration. When you see the after 20th iteration, the fitness value reaches around 0. The fitness value, you can see the fitness value reaches around 0.125 and remains nearly constant. This suggests that the algorithm has found an optimal or near optimal solution. Also, the exploitation stage starts here, where minor adjustments are made, but major improvements have already been achieved. Now, the convergence beyond 20 iteration, convergence beyond 20 iteration. This the model does not show significant improvement after this point. This suggests that further iterations do not contribute to better accuracy, and the algorithm has likely reached the global or local optimum. So basically, this ischemic heart disease squirrel search optimization model achieves good optimization in fewer than 20th iteration, make it computationally efficient. So the convergence curve indicates a well-balanced trade-off between exploration and exploitation. Now we'll see the comparison of the efficiency of different algorithms. So the here okay, so here there are different years and different it is compared with different years and different algorithms have discussed the accuracy different classifiers like naive bias, then bagging, SMO, neural network, ICA, KNN proposed. So our proposed algorithm, when you compare with all other algorithms, the proposed algorithm is in terms of accuracy, sensitivity, specificity is giving better result. So here GA, okay. So now this is the comparison of the accuracy of heart disease diagnosis. Here the figure represents the comparative analysis of different models for heart disease diagnosis based on the number of features used. There are 3 models compared here. The first model is GAKNN, that is nothing but genetic algorithm. I have compared here all the comparison. If you see, all are the population based thing only. So that GAKNN, that is genetic algorithm, that K nearest neighbor. So also the second one is ICA KNN, that is imperialist comparative algorithm nearest neighbor, K nearest neighbors. Then The proposed one is IHD SSO. So here when we observe this one, the accuracy is increasing for all models. Accuracy increases as more features are used, reaching a peak around 6 to 8 features. So that is why it is also beyond 8 features. Beyond 8 features, you can see the accuracy starts declining. So due to the curse of dimensionality, where redundant or irrelevant features negatively impact performance. So when we see that GA, that is genetic algorithm K nearest neighbor, it shows a steady but moderate, it is moderate improvement up to 4 features, reaching almost 0.75 accuracy. So here accuracy beyond 4 features and stabilized around 0.75. So these are all the number of features. The next one is ICA KNN. So this one, it outperforms genetic algorithm K nearest neighbor initially and reaches a peak accuracy around 0.85 at almost 6 to 7 features. So the accuracy then starts declining beyond 8 features. Then our proposed, that is the green color, proposed ischemic heart disease squirrel search optimization consistently outperforms both compare with GA-KNN as well as ICA-KNN. Also, it achieves the highest accuracy when you compare with all other meta-heuristic algorithm, because this proposed algorithm is meta-heuristic. So the comparison also made on the meta-heuristic algorithm achieves highest accuracy around the 7. Here you can see the highest accuracy found in almost between 6 to 8. That means when we are reaching the 7 features. So it shows better stability in accuracy between 6 to 10 features, making it more robust. Also, the optimal features count 6 to 8. The best accuracy is achieved when using around 6 to 8 features. So out of 13, it is giving the better result is between 6 to 10 features, so making it more robust. Also, the optimal feature count 6 to 8 features. The best accuracy is achieved when using around 6 to 8 features. Also, adding more features does not improve performance and may lead to overfitting or noise. So also it is compared with other analysis also. When we see other algorithms, the classifiers we have used, JNN, random tree, and all other algorithms, the proposed algorithms. So here, our proposed algorithm, the same, actually the data set is same. They are also using all these random forestry algorithm, even NB tree. So everyone using this, not same, this one meta-heuristic algorithm. Different meta-heuristic algorithms are also available, like crow search algorithm. It is kind of searching algorithms. Use many other searching algorithm, but still found that squirrel search is giving better. Almost 5 or 6, that 6 features only found that within 6 feature we are getting the better result. So the accuracy in terms of sensitivity 98.38, then the specificity 98.10, accuracy is 98.38, F score is 98.32. Then kappa, this one is 96.74. So this is giving better accuracy, even though the AN is giving 97.22 and 97.33, but still this particular squirrel search optimization giving better accuracy. Also, the result is compared with classification accuracies of the proposed model and the previous models that used for the heart disease data set only. So the year 2009 neural network ensembles received 89%. Then in the year 2012, the research happened. They used the same data set, used weighted fuzzy rules, got 62.35. Then the year 2017, ANN and fuzzy AHP received 91.10. If you see the curve day by day, year by year, it is like the accuracy level is increasing. Then in the year 2019, the optimized stacked SVM is getting 92.22. Then the 2020, the XGBoost using dataset with which encoded categorical features received 91.80. So this particular model developed in the year of 2024, last year, so received 98.38. So also here, the AUC chart of Bayesian optimization is compared with the XGBoost, random forest, extra tree, and proposed model. So when we see when we compare with all other trees like random forest, extra tree, then Bayesian optimization, XGBoost, the accuracy 98% we are getting based on this research optimization algorithm. All are almost nearby, but still there is a significant improvement is there when we use the meta-heuristic algorithm. Yeah. So the distributing the population, dynamic foraging behavior, seasonal adopting intelligence, and random repositioning of individuals. This is the experimental inferences. Also, we can handle the higher order data. Since it is used, the data set is very less. Also, it is tested with 20,000 heart disease data that is available in the Kaggle heart disease data set. You can search and find. It is easily downloadable. You will get it in CSV file. It's a numerical data set. Even that is with that data set also it is experimented. So both getting 98%. Also, there is no restriction for the number of attributes. So even we can give a number of attributes and use this particular algorithm, because since we have this searching technique, so this will also, we have so many number of iteration as well as so many number of subsets, so we can finally we will get very good attributes. So the number of attributes, there is no restriction for the total number of attributes. So also we saw that we are getting best convergence solution in terms of exploration and exploitation in optimization. Also, the various optimization algorithms exercised with the UCA heart disease data set for heart disease classification are compared to the proposed ischemic heart disease squirrel search optimization. In comparison, the proposed ischemic heart disease squirrel search optimization model performs better in terms of accuracy, sensitivity, specificity, precision, recall, F measure with other equivalent state-of-the-art algorithms. Also, on implementation, the proposed model will be incredibly helpful in supporting healthcare solutions for diagnosing the ischemic heart disease dataset. So this particular research is very, very interesting, as well as in day-to-day life, it is very much necessity, because day by day when we see the heart diseases are increasing day by day, people. So if we actually, if you ask where exactly this will be helpful, means it is just kind of screening purpose. When we go to the hospital, when they are taking some test, so the doctors can tell that they can just predict, and they can tell further for related heart disease test needs to be taken or not. If you are interested, really you can go through that, because this will be helpful for the society as well as our dear ones also. Thank you so much for giving me this opportunity. If you have any query, you can ask.
Madam, which are the powerful algorithm for future prediction?
Thank you, sir. Thank you.
Hello?
Thank you, sir. Tell me, sir.
So, which are the powerful algorithm for future prediction?
Future prediction, sir?
Yes, yes.
You are asking about feature selection, or you are asking in general the algorithm?
Algorithm, which are the powerful algorithm we can use for future prediction of diseases or something using AI?
Sir, you see, if you talk about the numerical data set, maybe I have experimented with this one, random forest, since it is a this one, we have decision trees, no? So it is giving better result. Suppose if you have the data set is in the, because now ECG, that image is also there. Suppose if you are predicting by using the images, maybe ECG image and EEG image, like that, so many images are there. Suppose if you want to go for that deep learning model, then better to go for LSTM, sir. I think LSTM will give you better result. Again, you can try with other hybrid method also, because even one model I have we have worked on hybrid method. So when we compare with this single algorithm and hybrid, we found that hybrid was giving the better result. So like that, if it depends on the data set, what data set you are using, you can go ahead, sir. Hello, sir.
Participants, any more questions you can ask? Okay. So good evening all. I would like to express our sincere thanks to our distinguished resource person, Dr. Sanita. Thank you so much, ma'am, for your excellent presentation. Your expertise and detailed explanation have provided us with clear understanding how future extraction plays a crucial role in data processing, machine learning, and deep learning applications. Thank you so much, ma'am, for your continuous support in the learning journey.
Thank you, sir.
Thank you. Dear participants, as we near the conclusion of our enriching program, it's time for two very important segments, that is, test and feedback. Please follow the instructions very carefully. Dear participants, please log in into your Atal individual page. Once you log in, left side of your screen, you will see an assessment in the menu bar. Okay. Click on the assessment. There will be a test link inside. Click on the test link and attend the online test. That is 25 multiple choice questions, which will be only available from 6:30 p.m. to 7:30 p.m. Once you completed the test, click on feedback in the menu bar, fill up the feedback form carefully. If both test and feedback were completed, your certificate will be uploaded automatically. Then you can download the certificate by clicking on the certificate in the menu bar. Once again, I repeat the instructions. Dear participants, please log on into your Atal individual page. Once you log in, left side of your screen, you will see assessment in the menu bar. Click on the assessment. There is a test link inside. Click on the test link and attend the online test. That is 25 multiple choice questions, which will be only available from 6:30 p.m. to 7:30 p.m. today. Once you completed the test, click on feedback in the menu bar. Fill up the feedback form carefully. If both test and feedback were completed, your certificate will be uploaded automatically. Then you can download the certificate by clicking on the certificate in the menu bar. Thank you so much for your participation. Thank you.